transformer, right? And transformer is something we just whatever the challenge that we are facing nowadays, okay, because of AI, generative AI, all because of this guy, okay, that is called transformer. Okay, this turns the story completely. Okay, earlier it was just the predictive kind of things we were working. Okay, generative was also we were working, but they were not that much smart enough. But transformer made the things very smart. Okay, whole generation process, okay, whatever the generation process that we are using, whole generation process becomes very smart because of presence of transformer. All right. So the kind of development, expected in next 30, 40 years, that kind of development happen in just 5, 6 years, right? So transformer is a big game changer, right? This thing came from a simple research paper that was attention all you need. Okay, attention all you need. Okay, so this is a research paper which was published, right? And in this research paper, actually, some informations were there, and based on that information, the transformer is created. Okay, here it was theoretically, but if something is theoretically present, okay, with the help of program, we can convert it into action. Okay, in this case, it is theoretically explained, but later on, with the help of programming and all, people converted it into a kind of a product which we called as a large language model. Okay, large language model means what? A model which is trained on very large amount of text data. Okay, we created a large language model. That means a model which is trained on a very large amount of text data. Fair enough? Okay. Now, we need to understand how it actually works, right? So let's say I'll try to explain it. Okay. So what is the purpose of transformer, first of all? Okay. So transformer, you can say, is a type. So we are moving next step from RNN. We are moving towards a transformer now. Okay, transformer. So first we'll try to understand its definition, and thereafter we'll try to understand its architecture, and then we will use it, right? So we can say it is a AI model, right? Just like learning model or training model, okay, which is used for understanding and generating languages. Okay, that was the purpose of it. Okay, now let's try to break this thing simple small units. Okay, so we know we can say that it's a special kind of machine that can actually read, right? Okay, that can read. It's a special, just a special, because machine don't consider it a hardware machine, it's a software machine. Okay, that can read, that can understand, right? That can generate what? Human languages. Okay, these are the things that transformer can do. Okay, so here we just pass some words as an input. We give some word as an input. It process them, right? So when we give any word as an input to the transformer, right? Okay, to the transformer. Okay, the full form of GPT is what? Generative pre-trained transformer. Okay, GPT means generative pre-trained transformer. So that is also a result of transformer only. Okay. So whatever the language model that we see nowadays, most of them are built on transformer, right? So it's like it just takes some words as an input, okay, and it process them using attention. Process them using, that is the important word I'm writing over here, attention. This is something that we have to understand, how it processes them using attention, okay, and then generates the meaningful word, okay, and then generates meaningful words, right? So attention is like what? See, when you read a newspaper or you read a book, you read an article, right? So after you read a book, article, newspaper, after that, if someone will ask you the story, that what a story you basically read, okay, like in a newspaper, in an article, in a book, okay, just summarize the story. So you will not kind of tell word by word, okay. You just give the, tell the story based upon what are the words that you paid attention, okay. So when you see anything, okay, our mind also pay attention to the very important words, okay. And while paying attention, we also find out a relation, right, like how each word are connected to each other, right. Like we know, like over here, generating is a word that is related to language in this whole sequence. So how do we know that generating is over related to language? Because we paid the attention. We just attentively we had seen this thing. So we also do a lot of things based on the attention. We just pay attention on the very important things. That gives us some meaning. Okay. We pay attention to those things that gives us some meaning. Right. We don't pay attention to anything which is meaningless, right? Or having a lesser meaning. Okay, or it is lesser important. Okay, lesser important thing we generally pay lesser attention, more important thing we pay more attention. So here the transformer as a machine will do the same thing, right? Let's take an example. Okay, let's say if I have to do, suppose I have to kind of do the translation, right? So if I have to do the translation, okay, like suppose I have to do the translation from English to, let's say, Hindi. Okay, why? Because these two languages I know, right? So it's like English is like, let's say, I am learning AI. Okay, so it is English. Now what will be the Hindi output of it? Hindi output will be what? मैं AI. If you can't read Hindi, it's okay. I'm just whatever language you can based on that you can relate this thing. So मैं I सीख रहा हूँ. Okay, it is not like that. If you don't know how to read Hindi, it's fine. Nothing to worry. Whatever language you know, based on that, you can relate it. So it is a Hindi, right? So now how it works actually. Okay, if I have to translate how it works. Okay, so first we read the whole sentence. Okay, we read this full English sentence. Okay, read full English sentence. Then only we can do what? We can convert into another language, right? So this part is called what? This part is called encoder part. That means we read the input, that is called encoder. Okay, and thereafter we are generating the Hindi sequence of it. Okay, once we read the input and thereafter we are generating the Hindi sequence of it. That is called what? Decoder. This is called decoder part. Okay, we have an encoder and then we have a decoder over here, right? So why I'm telling you this thing, that encoder and decoder? Because in the transformer architecture, if you see, we have these two things. Okay, the first part that you see over here is called encoder. Okay, this is called what? Encoder part. Okay, this side. Okay, this is called encoder part, and this is called what? Decoder part. Okay, so transformer architecture is having these two parts. Okay, these two entities. Again, how it works, right? So that's why we need to know what is the term actually encoder or decoder. So in the transformer, we have two major things. Okay, one is your encoder. If I'll just have to create the transformer architecture at a very higher level, right? So, just a minute. So transformer, which is used to learn from the text or the language data, it is having two things. One is called your encoder, okay, and other part is called what? Decoder. Okay, these are two things. Okay, so what encoder does? Okay, encoder is there to think very deeply about the input. Okay, that is the purpose of encoder. Okay, and what decoder does? It is being created to generate the output. Okay, that is the purpose of a decoder. All right. Okay, now we have to, kind of, so we know the purpose of encoder. The purpose of encoder over here is to think deeply about the input. Okay, and purpose of decoder is what? To generate the output. Right. So now we have to go into this detail. Okay, let's create the encoder block over here. Encoder block. I'll create and thereafter you can relate. Right. So the encoder block over here, if you see, is having what? Let's say we have the input, right? So we can say like this, we have a input. Okay. Thereafter, we have over here input embedding. That means we convert this thing into the numerical value, right? So here it is embedding. Sorry. Okay. Input and thereafter we have embedding. After embedding, what we have? Positional encoding. This is very important to understand. Okay. Where I'll explain it. Okay. Embedding, and then we have over here positional encoding. I'll explain it in detail, like what is positional encode. Don't worry. Right now, this is something that is done. Okay, so this is the first part of it. Okay, thereafter the actual. So these are the text pre-processing. Once the text pre-processing done, so next process starts from here. Okay, and which is your multi-head. Okay, multi-head self attention. Okay, multi-head self attention. Right. Thereafter, we will use what? Add and normalization. Okay, I'll explain each part of it. Thereafter, we have feed forward network. Okay, which is FFN. Okay, and then again we have, just a minute. Okay, and then again we have add and normalization. Okay, and then at the end we have an output. Okay, so this is what encoder does. Okay, this is what encoder does. Okay, input embedding, positional encoding, multi-attention, add and normalization, feed forward network, add and normalization, and then output. Right. So if we understand each layer over here, we can understand what actually encoder does. Okay, only you have to understand these layers. Okay, out of these layers, already you know up to here. Okay, up to here you already know. Okay, we have to just understand this thing, positional encoding and other factors. Right. So I have how many layers? 1, 2, 3, 4, 5, 6, 7. Out of 7 layer, 2 layer already you know. Okay, because output is just output. Only we have to understand the rest of the 5 layers. Right. So we'll try to figure it out. Next, we have a decoder block. No need to write it down. I'll share everything. Okay, in the notes, I'll share these details. Just try to understand. If you can note it down, it would be good. Okay, if you're writing it down, it would be a kind of a better, kind of understanding for you. But anyway, I'll share the complete thing with the notes, right? So decoder block is having what? Input. Okay, and thereafter the input, if you see over here, here output embedding is there. Output embedding means what? See, if I want to build a system which can do the translation, okay, if I want to build a system which can do the translation like this, just focus on the translation. Okay, don't worry about the next word prediction or anything. Just focus on the translation, right? So this guy will be given to whom? Will be given to input. That means encoder. This information will go to whom? Will go to encoder, right? And this information will go to whom? This information will go to decoder, right? Then only a machine can learn about the translation. Okay, if you don't give both the language, then how it will learn? Like suppose as a kid, if I have to learn, like suppose one language already I know, I have to learn the another language. So somehow we also create a relationship between what language we know and what language we are learning, right? That's how translation works. So this guy will be given to encoder and this will be given to decoder. So we are giving text data to the encoder and then we are giving the text data to the decoder. Correct. So if we are giving the text data to the decoder, so at the decoder also we require embedding. So that's why it is what? Output embedding. Right. So here also embedding will be there. Okay. After embedding, there will be positional encoding. So up to here it is same, just like decoder, sorry, just like encoder, same thing is done. After this, in the encoder, we were having the multi-head self-attention. Okay. Here also we have multi-head self-attention. Here also we have multi-head self-attention. But it is what? Masked multi-head self-attention. Masked. Okay, masked. Okay, what is masked? Masked is like something you mask, something you hide. Right? So what we do when we give this thing that I want my machine to learn about the translation. So what we do, we give this whole thing as an input to the encoder. But to the decoder, we don't give whole thing at once. We mask it. Okay, mask it like this. We just give the word man. Okay, and thereafter I expect my decoder to generate the next word. So after man, let's say next word is it is generating something like man anything. Okay, मैं चल मैं गा ऐसे करके like it is just generating any random word, right? Now we give the actual word so that it should learn that after मैं AI should be there according to this guy. So mask is like avoiding the decoder to cheat. We don't want decoder to cheat, so what we do, we mask it. Okay, we mask it like this. Okay, first we mask this whole thing. Okay, we mask it, right? Thereafter we inform about this about AI and we mask it. Okay, then we inform about seek, then we mask it, right? So as it will keep learning, that means first I ask the decoder, I give man and ask it tell me the next word. So decoder will tell me any random word. So that now I'll give AI. Now decoder will calculate the error between this one, this one, and then try to minimize the error. Okay, we'll try to minimize the error with the weights or that learning trainable parameters. It will try to minimize the error so that it can generate AI. So after minimizing the error, now this model will learn that after may what AI is there. Then may and AI is present. Then again I ask it to generate next word. So again it will generate some random next word. So now I'll give seek. Right. So again, error optimization. So in this way, it will keep learning each word one by one. That's why there's a difference. Over here, it is just multi-head attention, self-attention. Here it is multi-head self-attention, but masked. What is multi-head self-attention? Don't worry. I'll tell. Okay, this concept I'll tell. I just try to explain you a bit about the masked. Anyway, we'll again describe it in detail. After this, we have a add and normalization. What is add and normalization? We'll see, right? After this, we have what? Let's say encoder-decoder attention. Okay. See over here, if you see, okay, marks, add and normalization, and then over here the encoder came. Okay. Here encoder also came, right? So that means next thing is what? Now encoder came over here. So next we can say what? Encoder. Now encoder join the decoder. Encoder decoder attention. Okay. Now here encoder decoder join. And once it will join, again add a norm. So you can say add a normalization. At each layer, we are doing this thing. Right. Now we will do what next? Here. The same feed forward network like we did earlier. Right. Let me just try to make it little. Just a minute. Okay. And then after feed forward network, we have again add a normalization. Okay. And then we have a output. Right. So this is the architecture of our decoder. Right. So we had just created the architecture of encoder and decoder. Okay. Whatever it is there. Right. Now we'll try to break it down step by step so that we can understand how the process actually go through. Right. So this will, I'll just try to make, explain you in transformer in a very simple language so that, it's a very, kind of, okay, one more thing. When we use this thing, this is architecture. If you see, it is not like that to train a language model. This is just one unit. Okay. Similar to it, millions of units are used to which actually learns the complete thing, the complete language. Okay, this is just one unit, the architecture of one unit. It's not like that complete data you feed over here in the input and complete data into output. No, right? Anyway, we'll discover that. So, how process starts? As we know, step one, you give the input, and when we give the input, it is word embedding, right? That means step one we can see over here, tokenization, okay, and input embedding. Okay, just like any language model, this is the first step. Okay, what happened over here? You feed the text, that text is converted into numbers. Okay, and that numbers are converted into what? Vectors, that we had already seen. Okay, why? Because computer don't understand words, so we convert the words into numbers. Those are called tokens. And then to vectors. What are vectors? Vectors are list of number that captures the meaning of a particular word. Okay, vectors are those list of number that just try to capture the meaning of a particular word. That's it. Okay. So here we have an example. Okay. Let's say I have the text transformers are amazing. Okay. So now here transformers will be converted into some word, some numeric value, let's say 3, 4, 5 like this. Okay. Are okay amazing. Let's say over here 8763 something 873. Now now these numbers will be converted into vectors, right? Like 0 0.2, 0 0.4, minus 0 0.1, 0 0.3, okay, 0 0.1, 0 0.5, 0 0.7, 0 0.9. Okay, this is what? Minus 0 0.3, 0 0.8, 0 0.6, 0 0.9, right? Like this. Okay, so these vectors, that the computer can understand. Now, next step is what over here? That is called step 2. Now, from here, the story is little different. What we had seen, okay, that is your step 2. Okay, because here a new thing is added that is called positional, okay, encoding. What is positional encoding? Positional encoding answers who came first. Okay, that is positional encoding. Okay, why positional encoding is important? Because it don't work like RNN. Okay, RNN actually takes the word one by one to learn. Okay, RNN takes the first word, then second word, then third word, then fourth word, then fifth word to learn about it. Okay, to learn about the sequence. Transformer actually look all the word at once. Okay, like I have over transformers are amazing. So it's not like that it will pick the first word, then second word, then third word, then fourth word, then fifth word to learn about it. No, it will just look at all the words at the same time. Okay, just pick all the words at the same time. Correct. If it will pick all the words at the same time, then how it knows that which word come first, which word comes second, which word come third, right? Because it is just picking up all the word at once. Okay. If it is picking up all the words, all the numeric value at once to learn from it, right? So it's difficult to understand which word come first, which one come second, which one come third, right? So, the point over here is transformer look all words at once in one go, right? So they don't naturally knows or know the order. So it naturally don't know the order of the words, right? That's why we have to do what over here? Positional. We will do what? Positional encoding. Okay, that's why we do what? Positional encoding. Okay. So positional encoding actually adds the information about the word order. What it does, it just add the information about word order. Sorry, word order. Now, how it does it? Okay, like just like a time stamp, like a time stamp. Okay, so what it means? It means that transformer, if it is a word, let's say I have a sentence: transformers are amazing. Okay, this is a sentence I have. So transformers, okay, this will be converted into vector plus position 0. This will also be added. That means here the transformer vector, okay, transformer vector not just contain the vector, that vector will also have the information about position. Okay, same way R. Okay, this guy is not just a vector, normal vector like this. It is also containing the information that position 1. Okay, amazing. Okay, this will contain the information about position 2. Right. So here the vectors are not the vector that we created earlier. That was the vector that we created earlier. But here the vector will contain the information about the word as well as the position of the word. Right. So that your model can understand the order, how the words are arranged. Okay. Because if let's say I have over here, okay, any kind of words, if sentence, let's say he loves her, okay, and she loves him. So same kind of words are there, right? So if someone not knows about the orders, right, or machine don't learn about the orders, then how it learns that okay, both are different? Okay, so that's why ordering is important. Here the word ordering is very important, right? So that's why it's kind of a transformer trying to pick the words at once, but not just with a normal encoding, but with the positional encoding. Okay, how this positional encoding happens in the backend? It is done with the help of the dot product between the matrices. Okay, that means there will be a matrix. There is a, like this guy will be represented by a vector. Position will also be represented by a vector. We just do the dot product between these two things to generate a vector containing the what vector plus position vector. So that I'll show you actually how it happens mathematically also. As of now, let me just give the detail of complete architecture. It will take time. First of all, let me tell you, transformer architecture explanation will take time. Okay, so our next hands-on may start. Will take time. As of now, a lot of explanations are there actually, right? So we had just try to understand over here that embedding and then the concept of positional encoding. Okay, mathematically how it happens, we'll try to explore. Okay, now the next step over here is encoder block. Okay, this whole thing is your okay. This whole thing okay is your encoder block. This is what your encoder block. All right. So the third step over here, step 3. We here I'll just give you the initial intuition and thereafter we'll go into the depth of this encoder block. Okay. First we'll just have a initial understanding. Encoder block. Okay. What it does. This we can also call as a deep thinking machine. Encoder block is what? Is a deep thinking machine. Okay. So encoder actually do what? Encoder looks at whole sentence, okay, at once, okay, and asks few questions. It will just ask few questions. The first is related to self attention. Okay, so if I'm telling asks, so if it is asking these things, it doesn't like someone is sitting and asking. It is mathematically, everything will happen mathematically. Okay, these all things happen mathematically. There is a very complex maths behind it. Okay, so here it will just try to ask self attention. Okay, self attention is like each word in your document. Okay, each word that is present in the document, that will check. Okay, what check? Which other word, which other word, okay, it should pay attention to. Okay, now what it means? See, if I will give you a single text, okay, right? Let's say if I will give you over here a single text, let's say mm, dog, dog plays, dog play with ball. Okay, dog play with ball. Right. So now over here, if I give you this text, right? So now you can't understand which word should be paired. Like while looking at the play, where should I pay attention? Okay, you can't understand. But if I will give you multiple text over here, okay, let's say kid was playing with ball. Okay, ball uh, game is good to play. Okay, let's say I like playing with football. Okay, so now when I give you these much sentences, okay, now whenever you find the word ball, okay, in future, okay, whenever you find the word ball, okay, so you kind of you know that ball is something which is related to playing or game. Okay, because whatever the words, whatever the kind of a sentence that has been that you had studied, like suppose whatever the word that you studied or whatever the sentence you have studied, in those sentences whenever the ball was there, so play word was used. So this is called attention, right? Whenever you are reading the ball for the next time, okay, or you find a word ball, you will try to find out that whether play word is there around it or not, right? Or whenever you find a sentence in which ball is there, automatically your attention will be over the play word, right? So attention is the same thing. Okay, it is like machine learns with the amount of huge amount of data, right? For each word, okay, with each word it will just try to identify which other word is important. Like for the play, ball is important. Okay, for the ball, play is important. So each word checks which other word it should pay attention to, right? So for the ball, compare, because other words are changing. Okay, other words are changing, but with the ball, play is already present, right? So for the ball, okay, which word should be pay attention? Play should be pay attention. Okay, play, we have to give the more attention to play. Okay, for the word play, I have to give more attention to the word ball. Okay, so that with the huge amount of text, actually machine learns this thing. Okay, for each word, it just learns, right? That okay, these are the, so what are the important words for the particular. So this helps a machine to learn about that how words are related to each other, right? So this is what encoder do, that is called self attention. Okay, next over here in the encoder block we have a feed forward neural network. Okay, feed forward neural. So what it does, it actually process the attention info, whatever the information captured, okay, with the help of attention mechanism, it just process it. Okay, then the third step is what, add a normalization, that is called normalization, right? This will do what, normalizations and residuals you can say. This will just keeps learning stable, okay, and strong. Okay, because over here, you know it's like over here, after this we get certain values, some values may be very high, some value may be low, kind of thing. So by normalizing it, okay, so while normalizing, actually we do what, here when we feed the input, okay, and what output we are getting, we feed the input, we are getting the output. So these two things again we join. Okay, input we had given, okay, and then output we are getting. That output means what, it just identified that which word is paying a high, which word should be paying a high attention for each particular word, which other word should be paying the high attention. So that those are the matrix data, numerical vector will be there, numerical matrix will be there. Now these will combine and normalized. Okay, then again it will pass through the encoder decoder and then again normalize. So at each process we just normalize it so that the process should run stably. Otherwise values, either these are numerical values, so numerical value may be very, may goes, may become very large or may become very small, right? So this is a high level understanding. We'll go into deeper into it as well. We'll just try to understand in detail the normalization, how works, how self attention works, how feed forward works. But yeah, at a high level, as of now, I'm telling you. Now, next step is what? So first step is what? First step is just tokenization. Second step, positional encoding. Third step, we have an encoder. Data moves into encoder block. Okay. Now data comes out from the encoder block. And when it comes out from the encoder block, it will move into the decoder block. Okay. So what is decoder block? This is a decoder block. Okay. This is a decoder block. Right. So, okay. Right. So now a step, I guess 4. Okay. So step 4 is what? Decoder block, which is called talking back. Okay. So decoder do what? Decoder starts with nothing and generates one word at a time. Right. So the decoder starts with nothing. Okay. And generates one word at a time. Okay. That is what decoder does. Okay. So it just looks at, just like the process we did in RNN. Okay, same thing it do. Okay, it just look at what the word it has already generated. Okay, that is what we did here, right? It is we generated, so it's like first this one, then it generated never, then it will look at the word that it is already generated. Okay, and thereafter the next one. So similar kind of process. Okay, but it works in the form of decoder for the very large scale data. It learns from the large scale data. So it looks at word it has already generated. Okay, it will just look at this thing. Okay, and then it will look at the context from the encoder. Okay, so it will do what here? It will just first generate anything right from here. Okay, and then it will look from the context from this particular thing, that what encoder is saying. Okay, what encode it just identified something we had given. See, if I want to do over here, let's say translation. So for the translation encoder, in the encoder we had given the English language, right? I am learning AI. Okay, thereafter here we had given the Hindi language. May AI seek something like this, right? Now it's like, here, but it is marked. Now it will go over here, it will generate something, some output. Okay, and thereafter it will also try to get the context from the encoder like this, right? And based on this, it will try to understand that whatever the information that encoder is giving, and whatever the information it is having, and whatever it is generating, right? So how everything is related to each other. That means for a particular word to generate, which word is important over here? That means for may, if I want to generate may over here, so for the may, which word is important? That is done through this process, right? So that is what mentioned over here. Okay, I have to mention. It looks at what it has already generated, the first step. Okay, and second step, it will looks at the context. It looks at the context from the encoder. It looks at the context from the encoder, which is your input sentence. Okay, then it will pick the next word, right? So and based on that, this process will go again and again, and then it will pick the next word that we had given, right? After this, then it pick next word, okay, until the output is complete. Okay, so to keep picking up the next word okay, and trying to find out how encoder data coming from the encoder is related to the data it is having, and at the end it will try to generate the final output. Now to do all these things, how each layer is effective, that is what we have to understand. Okay, we know what happened, but how it happens, that we don't know. Okay, we know what happens, we have to understand how it happens, right? To understand how it happens, before that, let's try to have the last step over here, which is called fifth step. Okay, so fifth step does what? Here, final output, right? So here, the decoder, okay, chooses the most likely, okay, next word, like we did using RNN, same thing. It will just choose the most likely next word, right, using something like softmax. Okay, using something like softmax, right? So now what is this softmax? See, at the end, if you see softmax is there, see here in our model, okay, we had used over here something, let's see, here we had used, at the last we have used activation layer sigmoid. Why we are using the activation layer sigmoid? Because the final output needs to be 0 or 1, or close to 0 or close to 1. But if I don't use sigmoid, already explained you, okay, it will give me the output from minus infinity to positive infinity. Sigmoid will just scale them down in the range of 0 to 1 so that error optimization can be done better. So to reduce them in the range of 0 to 1, apart from sigmoid, there is one more activation function called softmax. Okay. So what softmax does? Let's try to understand. Okay. Here I can also use softmax, right? So let's say I have, you know, 4 neurons, okay, or 5 neurons, right? Now this guy get a value what? 3, this guy get a value -2, this guy get a value 7, this guy get a value 8, this guy get a value suppose -2 or -5. Okay, fine. Now if I have to calculate the probability of each of them, right? So how can I calculate? For the first one, it is 3 plus -2 plus 7 plus 8 plus -5. So this minus I can't use, right? Not possible. I can't use because minus is subtracting it. This is the incorrect way of calculating probability. So how can I calculate the probability of this guy? Right? So I can't convert into +2 as well, because -2 and because -2 is saying something about this neuron. Okay, -2 is something about this neuron. If this neuron get a value -2, it is output neuron. So in the output neuron, we got some these values. So if output neuron is getting -2, so this -2 is telling something about this neuron, whether this neuron is, important, not important, close to 0, close to 1, something. So I can't make it +2. So what do? We use a process over here that is called exponential. So this guy will automatically convert this thing into positive, right? And also keep the magnitude according to negative or positive, right? If I will show you, let's say, if I will just write it over here, print np.exp of 2, right? And then I'll also put over here np.exp of -2. All right. So here you can see this is 0.13. This is, so, it is not negative. So, exp actually does what? Exponential will just convert them into positive term, right? So now all of them will get the positive value, right? And this will also help us in calculating the probability, right? That means whatever the output that you get over here, Here you get something, here you get something, here you get something, here you get something, and all of the sum will become what? One. Right. So softmax actually help us. Here I can use softmax also. That is called softmax. Okay. It will convert the value in the range of 0 to 1. Okay. Right. So that just like sigmoid, but the formula is different. Okay. So if I use softmax activation function, then also my model will perform well. Okay. And everything will remain same. Right. So that is what mentioned over here, softmax. Right. That is what I also mentioned. So the decoder will choose that which word is most likely based on the softmax. All right. And this process will continue. The process until the full output is generated. Okay. That means whatever we do till now, okay, almost the same thing is going to happen. Okay. Almost 50% of the thing will be same. Okay, whatever we did over here, okay, almost 50% of the thing is going to be seen, right? So here also what happened, like I feed India. So after India, it will try to find out, my model will try to find out the next highest probable word, right? Then those two words combined to find out next highest probable word. Then those three words combined to predict next highest probable words, right? So that's how process will happen, right? So here it's like when we have, okay, we have, we are just training a model, right? Like transformers, sorry, okay, transformers are amazing. Okay, so based on the learning, the decoder will do what? When you give this thing to the input, okay, decoder, encoder-decoder architecture learned that when the transformer will, what will be there? So for the transformer, the highest, kind of this thing, what is it? Attention should be given to the transformer only, because transformer Hindi is, I guess, transformer only. Okay, amazing, for amazing, the highest, what attention should be given to Adbhut. Okay, Adbhut, you can just write it over here. Adbhut and Han. Right. So it learns, and based on this, it can easily translate. Right. So overall, we have five things: tokenization and embedding, positional encoding, encoder that understands the whole input sequence, decoder that generates the output word by word, right? Using the input context, right? It's like, I'll just write the summary over here, because these are the things we are going to deep dive in the next class. Okay. So we have, first step is tokenization and embedding. Okay. Which is like word is converted into numbers. It is converted into vectors. Right. Next, positional encoding. Okay. What it does, adds word order, info. It will add the word order info. Then we have an encoder. What it does, understand the whole input sentence. Okay. Then we have a decoder. It will generate output word by word. It will just generate the output word by word using input context. Okay. And then we have a final output. Okay. So it will just try to predict the best word each time until finished. All right, that is what we'll do. So we can say transformer read an input, understand the meaning using attention, and generates a smart output one by one. Okay. So what we have to learn in the next class, we have to learn what is self-attention. Okay. If we can learn, if we understand this particular thing, what is self-attention, 50% of the transformer is done. Okay. Not 50%, I guess 70%. Okay. And then we will try to understand the decoder. Okay. And then we will also try to focus on what is multi-head attention. First, this self-attention and multi-head attention will try to learn separately. This is self-attention. First, we try to understand, and thereafter we'll try to understand this multi-head attention. Okay. Collectively, we'll try, and thereafter it will be clear for us that how actually transformer works. Right. And thereafter we'll try to use it using GPT or BERT kind of things. Okay. The notes about this thing I'll provide to you that you can easily go through. I just try to explain the architecture, initial level of architecture, where transformer is having two things. One is called encoder, other is called decoder. Right? Encoder is having over here the multi-head self-attention. Okay, add a normalization, feed forward network, and add a normalization. Right. So when we give the input data, so that input data first get okay, first get embedded, and then after positional encoding is done, and after positional encoding it goes to the multi-head self-attention, right? So multi-head self-attention is like, we can understand if we understand the self-attention. Okay, so here first we need to understand, just a minute. Okay, first we need to understand over here what the self-attention, right? If we have a fair understanding of self-attention, okay, we can easily understand the multi-head self-attention, right? So what's the purpose of self-attention? Okay, so the purpose of self-attention is like it let the each word in the sentence focus on other words, okay, that are most relevant to its meaning. Okay, like for example, I will write over here, let's say I buy a red car. Okay. Now for this particular word, car. Okay. Which particular word is very important to for understanding its meaning? Obviously, red. Red is very important. Right. So what self-attention does here, each word, that means this word will try to find out which other word is important for it. This word will try to find out which other word is important for it. This word will try to find out which other word is important for it. And this word will find out which other word is important for it. Okay. And that thing it will find out, that thing it learns because it has been given a huge amount of data. Right. So here what happened? Each word, it let the each word, okay, in a sentence, okay, focus on the other word or the word that are most relevant to its meaning. Okay, that is the purpose of it. Right. So let's say I have a sentence, any sentence I can say over here. Let's say the cat sat on the mat, right? Because it was tired. Okay, like this. Right. So here, what if I'll ask it over a question? What does it refer to? Okay, it, right? So here answer can be what? Cat, right? So basically, to make the sense out of it, okay, a model should actually understand what a model should understand. A model should understand that okay, it should refer back to what cat. Okay, it should refer back to what. So how a model learns about it? Because it is what? It is a kind of preposition. So wherever it is a preposition from the huge amount of text data, model learns that whenever it is having the preposition, okay, that preposition, kind of must refers to something called noun, right? So it is like that. That's how it actually learns, right? So here the self-attention helps the model figure that out of, you know letting the every word look at, okay, instead of just look at all the words, okay. Like it's not like that, it is just going for each word one by one, like out of letting every word look at the other words and decide which one is important, okay. It will just look at the other words that is present in the sentence, and with the help of self attention it will try to identify which one is very important for it, okay. Like for example, if there is a sentence like we had used in last class, okay, transformers, okay, are amazing, okay. So in this case, amazing is describing what? Transformer, okay. It is describing what? Transformer. It is not describing R, right? Amazing is not describing R. So here self-attention actually learns that transformer attends amazing, okay. This is attending amazing, okay. And R is least important in this particular sentence, and amazing is attending backward transformer, okay. That is what self, and that means here when we give any sentence, it just try to learn from the huge amount of data that how each words are related to others. All right. So it's like noun is related to adjectives, verbs, right? Pronouns are, sorry, here it was a pronoun. I use the term preposition. It is what? Pronoun. Pronouns are related to nouns and other things, right? So that's how we, based on using the huge amount of word, it just try to learn it. Now, question is how? Okay. So there is a complete mathematics behind it. We'll also come to that mathematical part. Okay. But first, it's like how it actually learns. Okay. So to learn these things, there is something called QKV. Okay. This is what helps to learn it. Okay. QKV. Right. So what are these things? Here, QKV are basically the vectors. Okay. Each word, okay, each word, like transformers are amazing. Each word will create three vectors. Why three vectors? So that attention mechanism can work. Okay, we want attention to work. Attention helps in what? Attention helps in identifying the important word for each word. Like for transformer, amazing is important. For amazing, transformer is important. So to do those things, these are the three vectors. That means each word will create three vectors. Okay, because everything is controlled by numbers, right? So it will also control by numbers. So Q is representing query. Q. Okay, it means what? What am I looking for? Okay, that means this vector will represent that what am I looking for. That means for the transformer. Okay, like this here the sentence is transformers are amazing. Okay, this will have Q, this will also have Q, this will also have Q, right? So Q will is a representation of what transformer is looking for. Okay, how this vector will be created, we will learn. Please don't worry. First, understand the theoretical thing. Thereafter, I'll explain you those things, right? Second thing is what? Key. Each word will have one more vector which is called key. Key means what? What do I offer? This is a vector representation of what do I offer. That means what a particular word is offering. right? Then the third is what? Value, that is V. Okay, this is what do I say if you pay attention to me. Okay, this is what, this is about the words. Okay, like transformer is creating, for the transformer we will have three vectors. One vector will represent that what transformer is looking for. Okay, in this sentence, in this particular sentence, what transformer is looking for. Second, what transformer is offering, that will represent other vector k, and the v will represent what I will offer if you look at me. All right, so it may be looking little, kind of, you may be kind of wondering like what is all the, what all these are. Don't worry, everything will get very much clear. Okay, just as of now, just take it like a story. Okay, just take it, don't think beyond it. Like don't think like, okay, what KQ we will do, how it will work. Don't worry, that I'll explain. Like it's my responsibility, right? As of now, just take it as a story. That for each word we have, for this guy we have Q, K, and V. Okay, for this word we have Q, K, and V. Okay, for this word we will have K, Q, K, and V. For each word we will have these three vectors. Okay, now for each word we will calculate the attention score. That would be equals to Q dot product K. Okay, dot product between the query dot product between query and key. All right. So this score actually tells the model how much focus one word should give to other. Okay, whatever the score we will get, we'll also calculate the score mathematically. Okay, so this score tells the model, right, how much, focus, or you can say attention, how much focus or attention word should give to another. Okay, like that. Okay, so the step is very simple. First, we have to compute the dot product between the query and all the keys, right? Thereafter, you have to apply, okay, fine. Let me just do this thing, mathematically one by one so that you can get it better. All right. Otherwise, if I try to kind of explain it theoretically, just a minute. Okay, so we'll just try to do this thing, one by one, step by step, so that we can understand it better, right? So let's see. I have to take example over here. Let me take example. Just a minute. Actually, I just want the example over here. I have a very good example. Actually, some calculations are there. So I'm just checking out. I did some of the calculation. Otherwise, if I define everything and thereafter I'll do the calculation, it will take some time. So I have the example in which I did all sorts of calculation. So it will be quickly, I can explain you this particular concept. That means these all metrics, like, your dot product and other things are there. So if I will use the calculation that I already did, I can explain. Okay, fine. Okay. So let's say here for the attention, what is required? The core formula for the attention over here. So we did what? We understood that every word will have three vectors, Q, K, and V, right? And core formula, just keep in mind this particular formula. Attention, Q, K, V. The formula for this one is equals to what? Soft Q multiplied by KT, that is a transpose, okay, divided by, okay, the square root of D underscore K, okay, multiplied by V. Okay, this will get clear. And then here softmax we use, right? So already I told you what Q represents. Q represents that what? Okay, let me write it over here. Q will represents what I am looking for. What I am looking for. Okay. K will represents what? This is called key. Okay. What you offer. Okay. Then over here V means value. This will be equals to what? What you say. Okay. And then dk. Okay, that I wrote over here. Dk is nothing, it is just dimension. Okay. Dimension of k. So it did what? It just do the scaling. Okay, scaling of your scaling factor for stability. Okay, it will just scale your value so that values should not get very large or something like that. So now let's say I have a sentence, transformers are amazing, right? So as I have a sentence over here, transformers are amazing, right? So now here, I have to apply this whole formula so that attention score can be calculated. Okay, so for that, first I have to do the word embedding. So let's say I did the word embedding and I get this particular value. Transformers, let's say, is represented by 0 0.1, 0 0.3, 0 0.2, and 0 0.4. All right. Okay. Thereafter, we have R. R is represented by over here. Let's say 0 0.0, just random number I'm taking, 0 0.1, not exactly random. Okay, these numbers I have used only to calculate, so that's why I'm taking it, so that I can do so the calculated output quickly. Thereafter, the amazing is, let's say, represented by 0 0.5, 0 0.2, 0 0.1, and 0 0.3. So these are the embedded form of these words, right? Initial word embedding. Now for each word, okay, that we have, again, for each word that we have, we will calculate what? Q, K, and V. Okay, so over here the next step is what? Each word, because each word should know that which other words should be pay attention. Transformers should know that it should pay attention to R or amazing. Okay, amazing should know it should pay attention to whom, right? So here each word, okay, each word embedding. Just a minute. Each word embedding, right, goes through three linear layers, okay, to produce. Okay, what to produce? Q, K, and V. So this will be equals to what? X. What is X? This guy is representing your X. Okay, X, that means the already existing vector multiplied by W underscore Q. This is a weight matrix. Okay, what is weight matrix? That means your model will learn about these weight matrix. Okay, it will just learn about these weight matrix, like I told you, like when I was explaining you the neural network and all. Okay, in the neural network, what happened? There is a feed forward process, right? So we have an input neuron, we have a hidden neuron, we have output neuron. So in the feed forward process, again, these weights are defined. First we define these weights, then we calculate the output, Based on the output, we calculate the error, and then backward propagation will optimize these weights. Okay, so multiple to and fro. Finally, let the model know about the best weight, about the best possible weight, which can give you the best accuracy. So similarly, here we have some weight matrix. Okay, we just have a weight matrix. So these are basically, if I talk about WQ, okay, WK and WV, okay, are trained. Okay, these are actually trainable parameters. So these will get trained to learn, okay, during the process of learning, what kind of queries, what kind of queries, queries means Q, keys and values are useful. That is the purpose of it. All right. So now what happened when you do this thing? Okay, like any value of WQ you are using, whatever value. Okay, let's say we are using over here 111, 222, anything. Okay, let's say we use over here WQ. Let's say we use over here, let's say 2. Okay, here we use, let's say anything. Let's say 1. Okay, here let's say use 2. Anything we can use, right? Because ultimately it will learn from like during the process of training, it will learn, right? So now here I'll create a table. Okay, in this table, the first I'll represent over here the word. Okay, so let's say here is word. Okay, so here it's like transformers are amazing, right? Here it's like we have a Q, K, V. So when we apply, use any kind of weight over here, and it will multiply with the existing this thing, that is your vector, right? So we get some output over here, right? So here we get some value of Q, like 0.2, 0.1, something like this, right? Here also we get, let's say 0.0, 0.2, something like this. Here we get what? 0.3, 0.2, okay, like this, right? Same way for the K, 0.3, 0.4, okay, 0.1, okay, 0.1, okay. Then we have 0.2, 0.3, like this, 0.7, 0.5, okay, 0.1. I'm just writing it something like this, 0.0, okay, and then 0.6, 0.4, like this. Right. So this value we are getting because of this particular formula. That means the given embedded vector multiplied with some weight matrix. All right. Next, what happened? We have to calculate the attention score. And what is attention score? Attention score will be, now step 3 is what? Step 3. We have to calculate attention score. What is attention score? Attention score is like Q multiplied by K transpose. Okay, that means if this is a Q for transformer, okay, Q for transformer is what? 0.2, 0.1, okay, and you can be anything. Let it be 0.1 once again, okay, and K for transformer is what? This guy. This is a K for transformer. Okay, so 0.3, 0.4, 0. Let's say 1. So here we take the transpose, okay, and then we take the product of it, right? So when you take the product of it, it would be what? 0.2 multiplied by 0.3, that would be 0.6 plus, so 0.06, okay, 0.3 into 2, 6, right, plus 0.04 plus 0.01. So that would be equals to what? 0.4156, 0.11. Okay. So here we will have the value Q1, K1. Okay, it would be like this. I'll just write it of Q1, that is for the transformer, Q2 and Q3. Here I write K1, K2, K3. Right. So here I'm getting what 0.11, for example. Okay. Now what happened? So this particular thing, this vector, okay, and this vector we did. Now we do what? We do this vector and this vector. Okay, we do this thing, right? So it means what? We have to write over here, okay, Q1 like this 0.2, 0.1, and 0.1. Okay, this time. Okay, so it's like 0.1, 0.2, 0. Okay, so 0.2, 0.1, and let's say 0.1. Okay, this will be multiplied by this guy 0.1, 0.1, and 0. Let's say 2. Right. So it will be what 0.02 plus 0.01 plus 0.02. That would be equals to what? 213, 22415. Okay, 0.05. So here it will be 0.05. Okay. Now this will be multiplied with whom? This guy. Okay. So again we get some value over here. Right. So let's say 0.7. Okay, some random value. Right. Now what happened? Q2. Okay, that's this time. Okay, this guy. Okay. This guy will be multiplied with this guy. Okay, then this guy, and then this guy. One by one. Right. So over here, it's like 0.3, 0.1. Some random values will be, some output will be, I'm just writing it a value. Now, this thing will be, like this. Okay. This will be multiplied with this one, and this one. Right. So we'll again get some numerical value over here. Let's say 0.7, 0.5, and 0.9, something like this. Right. So again, let's go through the process. First of all, we have a word embedding. With the word embedding, we just define some weight. Okay, that is a randomly defined weight. Okay, we don't know anything about it, but we just define something, some number. Right. Based on that number, for each word, okay, like for the transformer, okay, for the transformer Q will be calculated, for the transformer K will be calculated, and for the transformer V will be calculated. 3 vector came. Then for the R, okay, Q will be calculated, for the R K will be calculated, and for the R V will be calculated. Then for amazing Q, amazing K, and amazing V. Right. Now we are trying to calculate the attention score. Okay, that is this thing with itself, then this thing with this one, then this thing with this one. Okay, so it means what? This particular thing is representing what? Transformers. Okay, the transformers attends to. Okay, transformer attends to. This is what? Transformer attends to transformer. This is transformer attends to R. And this is transformer attends to what? Amazing. Right? That's why I said what? K is representing what? Okay, AJ, what you offer. Okay, that means when the vector of transformer, okay, vector of transformer multiplies with itself. So obviously with itself, it is getting maximum. Okay, fortunately, I just took the random value, but it is obviously with itself, it would be maximum. Then this guy multiplied with the K of R. So K of R, this one. Then this guy is multiplied with K of amazing, this one. So this is highest, then this is next to it. Right. So based on it, system will learn. Okay, that for this guy, this is important. All right. Now this will be, now you may think like how it will be only if R can also be more. Yes, obviously, this value can also be more. But this process don't done on a single sentence. These process actually done on huge amount of text data, right? So when it is done on a huge amount of text data, the model when learns iteratively again and again, it finds out that for each word, which particular other word is important. Again, like for each, like suppose with transformers multiple times, adjectives are coming. Okay, so automatically transformer is a noun adjective, so it's like it will learn that it will start managing this particular weight value, because total depends upon what weight. Okay, it just tune the weights value in the backward propagation, so that you know these can increase based on the huge amount of data given to it. Okay, this is what R. Okay, R attending to transformer, R attending to itself, R attending to amazing. This is representing what? Amazing. Okay, so amazing attending to it. Sorry, amazing attending to transformer, amazing attending to R, amazing attending to itself. All right. Okay. So now what happened? We have to stabilize the training. Okay, so for stabilizing the training, we do what? We basically, that means, because these values sometimes becomes very big or a small kind of thing, right? Because weights are involved and so many things are involved. So for step 4 is like scale and softmax. So first try to understand scale. Now to stabilize, okay, training, okay, we divide by dk, right? So what I mentioned over here, dk. Dk is like dimension of k, a scaling factor. This scaling factor we can choose, different, like when you are using transformer architecture and all, we can just choose. Okay, so here let's say if it is we are choosing 4, so it will be a scale by 2. Okay, depending upon it, right? Like for example, if this is what we are choosing, so the first row, first row that we have, first row, that is equals to what? 0 0.11, 0 0.05, 0 0.7. Okay, that will become what? 0. What? 0 0.11 divided by 2 is what? Just a minute. 0 0.11 divided by 2 is 0.055, and 0.05 divided by 2 is what? 0.025, and 0.7 divided by 2 is what? 0.35. Okay, so it is like just stabilizing the thing, so that these values can scale down, right? Now we do what? Once it is done, thereafter we apply over here what? Softmax. Okay, then we apply softmax. Okay, softmax on 0.055. Okay, then 0.025. Okay, and 0.35. Okay, this is what we apply. Okay, so what is softmax over here? Softmax will calculate this thing. E 0.055 divided by E 0.055 plus exponential value of E 0.025 plus E 0.35. Okay, this is for the first word, transformer to itself. Okay, now we are doing it because sometimes you may get a negative value, sometimes you may get a positive value, anything you can get, right? That's why we are using it. Now E, and we are, if I don't stabilize it, if I don't scale it, okay, these exponential value may be huge or maybe very small. Okay, so we also, that's also the reason we have to, because kind of, if you're dividing everything by 2, say it's like all of them we are scaling down in the same scale, so overall effect will be negligible. 0.055 plus E 0.025 plus E 0.35. Okay, here it is E 0.35 upon E 0.055 plus E 0.025 plus E 0.35. Okay, so we calculate these things, right? So when we calculate these things, we get certain values. Okay, let's say am I getting 0.41, you can calculate whatever you're getting. I'm just kind of considering some value. Let's say here I'm getting 0.27 and here I'm getting 0.32. Okay, so what does it mean? It means that transformers, this is a word, okay? Transformer word in the sentence is giving 41% weight to itself, okay? 27% weight to R, okay? And 32% weight to amazing, okay? It means this one, right? And based on this, now what we do? So this is the, with this thing we can find out that how, weights, how much weights are given. Okay, now we have to calculate the attention weights, okay, to combine your v vector. That means the last vector that we have over here, that vector we have not used yet. Okay, this is a vector that we have not used it, right? So what we do now, we will do what? Step 5. Step 5. Okay, here weighted sum, what? Weighted sum of value vectors. What? Weighted sum of value vectors. Okay, so here output 1 is equals to 0.41 into V1 plus 0.27 into V2 plus 0.32 into V3. What it means? 0.41 multiplied by whatever the things we have over here. Okay, that we calculated. So V is what you say. Okay, what I said, like what do I say if you pay attention to me? That is what V. How we calculated V? This is how we calculated V. Right. So now 0.7, 0.5, whatever it is, 0.7, 0.5, 0.4, like this, right? Plus 0.27 multiplied by 0.1, 0.8, okay, 0.3 plus 0.32 multiplied by 0.6, 0.4, 0.3, like this, right? So this is how we calculate. Now the new output vector, this will give you obviously a new output vector, right? uh, as the at the end, right, we'll get a single output vector. So that new output vector is actually the context aware version of transformer. Okay, like see, it will be what? Here 0.54 multiplied by 0.7, it will get 0. Something 0. Let's say 0.28 something. Okay, 0.028 something, you'll get it right. So let me just calculate it only. I'll show you. Okay, 0.41 multiplied by 0.7. This is 0.287 or something. Okay, let me just do it. 0.287. Okay, then this one is 0.41 multiplied by over here 0.5, 0.205. Okay, thereafter 0. This one will multiply 0.4, 0.164. Okay, plus then here it's like 0.27 multiplied by 0.1, that is, sorry, 0.27 multiplied by 0.1, 0.027, Okay, this one is multiplied by this one, 0.8, 0.216. Okay, this one is multiplied by this one, that is 0.3, 0.081. Okay, plus here 0.32, 0.32 multiplied by 0.6, 0.192, right? Thereafter, it's like 0.4, 0.128. Thereafter, 0.3, 0.096. Okay, something like this. Now I have to add all of them. So to add, what you do? It's like 0.287 plus 0.027 plus 0.192. This is 0.506. Okay. Thereafter, 0.205 plus 0.216 plus 0.128. Okay. So this will be equals to what? 0.549. Okay. And thereafter 0.164 plus 0.081 plus 0.096, 0.341. So now it is what? Here we get the vector at the end, which is representing your complete, like here we over here get the vector, okay, the weighted sum. This vector is representing your sentence, okay, and this vector is what is context aware. Okay, this is what context aware. Context awareness is very important. Okay, if something, this all process we do for what, so that my sentence or my text we are giving, my machine should be context, is to learn about the context. Okay, so the new vector that we are getting is a context aware version of transformers. Okay, transformers word. Okay, the transformer is amazing, and it actually now knows it's amazing. Okay, this vector, this numerical information, so you can see this, the journey over here. Initially we were having the random, random kind of embedding, not random embedding, but it is being just representing a vector of the word. Okay, so now these vectors actually don't know what is amazing, what is R, anything. It just know about what transformer. Okay, this knows only about transformer. This is R, this is only. This don't know that there is something called amazing which is important for it. This don't know that there is something called R which is amazing, which is important for it. Right. So now what happened? We created a weight matrix. Okay, defined a weight matrix, that as when I'm saying weight matrix, that means it is a trainable parameter which will change during the process of training. All right. So with the help of weight matrix, we calculated some vector like Q, K, and V. Okay, based on this Q, K, and V, we'll calculate the attention scope, right? So it's like we can just use this particular formula, right? Now we scale it and pass it to the softmax. With the softmax, we get something. Okay. Now this value, this process will go to and fro. On the, like, suppose first we had given a word like transformers are amazing, right? So it may possible this process can give the higher preference to R. That means when I'm giving the first sentence, first time I had given the sentence transformers are amazing, right? So it may possible this whole process will give kind of, will work like that, that transformer will give the higher importance to R compared to amazing. In the first attempt, transformer will give the higher preference to R. That means this value will be more, this particular, this will be more compared to this, right? So in that case, what happened? That's fine. Then again, some words I'm giving. Again, I'm giving more words. Like for example, dog barks when it is hungry. Okay, dog is kind of barking too much. Okay, so dog. I find a dog who was barking. It was I find a dog who was barking. Okay, so it's like multiple sentence when we provide. So when we, let's say, provide the first sentence. Sorry. Okay, let's say over here, dog barks when it is hungry. So in this case, what happened? It may possible dog will give the higher preference to is. It's fine. But then again, I feed more sentence, right? About the dog. So like say, it barks. Okay, it barks when dog. Okay, I'm adding something nonsense. So dog bark when it find someone unknown. Okay, so now with this thing, now it will learn. Okay, so now it may find, it gives the higher preference to when, because when is used over here and here in both the sentence, right? So the weights matrix will optimize itself. Now I said dog. Okay, let's say one more sentence. Some dogs keep barking unnecessarily. Unnecessary. Now when it get this sentence, here when is not used, but now it finds that there is bark is also there over here, right? So by multiple trainings, okay, your model, actually your LLM model like GPT, they now learns that for a particular word, which word is important. Okay, first time it had given this thing, next time again weight matrix optimized. As the weight matrix optimized, this particular matrix, these value gets optimized. As it is get optimized, QKB updated. As QKB updated, this attention score updated. Based on the attention score, this softmax value updated, and based on the softmax score, this value updated. Right. So in this way, for each, so it's like, for this is representing what? This is actually context. This particular last thing is context away. It knows that with the transformer, transformer word should give which word a higher preference. That information is present in this arrangement of the numbers. We may be thinking like how a number is having that kind of information, because this number is not a random number. It's been calculated after a long process, right? So same way for the dog also, after multiple processes, okay, for the dog, okay, for the dog, there would be a matrix defined, okay, there would be a vector defined, okay, like this, okay, and this vector will have all the information about the dog, okay, like dog barks, okay, dog is a pet, dog bites, okay, dog kinds of sleeps a lot, right? So in this way, all the information about the dog is present in this vector, okay, and that vector is being created based upon the language text that we had given, right? Like for example, after, like, over here we identified, uh, here it's like we take this first row. The first row is about what? Is for the transformer, okay, this is for the transformer, how transformer is looking at each word, okay. Now we take this first row, and this first row we did what? We scaled, right? From the scaled value we had given it to softmax. So now we know that how transformer is giving the preference to each of them, right? Now that value, that means this is representing what? Transformer, okay, how transformer is giving preference to each other word. Same way there will be a matrix for R. Same way there will be a matrix for what? There will be a representation of what? Amazing, right? So now when we put this thing into vector over here that we defined, we get the output, right? So this is a process in which about the each word GPT knows, okay, about apple, okay. So GPT, when you will use the word apple, okay, so apple can represent what? Fruit. Apple can also represent the company, right? So how GPT knows that when you are talking about the company, when you are talking about the fruit? Because of this context aware vector. Okay, because of this context aware vector. Okay, Apple has been, context awareness vector. Okay, it is some numbers are there, right? So for the fruit, this is different. Okay, for the company, this is different. Okay, now when you give a sentence, the other words you give, like suppose if you're giving over here, apple is good for health. Okay, now health word is there. So health related, okay, health related information is present in the context vector of apple, which is fruit. Okay, health related information is present in the context vector, which is fruit. Right, now apple creates good phone. Right. So now phone related information, okay, phone related information is present in a vector. Okay, phone related information like is present in a vector for that apple, which is a company. Okay, phone related information is present in the vector for that apple, which is actually a company. That's why when we talk about, when we are putting this thing into the sentence, so the context over here identified that you are talking about the apple company. Here it is identified that you're talking about the fruit, right? So this attention mechanism actually helps to create a vector for each word. Okay, in this world, or whatever the size of data that GPT or any such model had used, okay, 1,000 words, 10,000 words, 1 million words, 10 million words, or 100 million words, whatever the million, whatever the size of word they had using, billion word, right? So for each word there is a vector, and that vector is not the normal vector that we created in RNN. Okay, that vector of words is actually so powerful that when you give any, when you write a sentence, that vector helps to identify that in which context you are using that word, and based on the context, that vector helps the model to understand or learn about the particular information that you are giving to it or asking it. That's why, because of this thing, you can use your language, natural language, to interact with the GPT or Gemini or ABCD, whatever, right? So the process over here, let me summarize it for you. See, this attention process is just for your understanding. You are not going to use it anywhere. Trust me, we have to use GPT. We are not going to use it practically. Okay? We are not going to use it practically in GPT, Gemini, or any application. Okay, whatever the application we have to create, okay, whatever the software that we have to create, application we have to create, or anything we have to create, okay, in anything we are not going to use this particular concept. Okay, this concept, even if most of the trainings, people don't cover this thing as well, because obviously this is not practically useful. Okay, and this is very risky as well. Okay, it is very risky to cover this thing, because sometimes if someone wants to go deep and cover these things, people don't find it useful, and people say that why are you kind of covering all this thing even it is not so practically important. But I do take this particular risk because I just want at least one of you or two of you, I'm not saying that everyone, if one or two of you actually interested in this particular thing, how attention works, how transformer works. So, it can be, you can just keep this thing into your logbooks, right? So the technology that is about to come in future, okay, because it's not going to end with the GPT, it's not going to end with whatever that we see. Lot of, in next 10 years, we are going to see whatever the development we had seen. Compared to that, you can say 100% of the more developments. Okay, agents just started. Okay, agents, AI agents, so many things just started. So whatever the technology that we are going to see in coming future, okay, to understand those technology, to learn, grasp the information about it, okay, if you have these understanding, okay, just keep this thing into your mind and just recall this particular thing after 3 or 5 years, right? If you have these kind of basic understanding, even I'll share the notes with you. Obviously you can't memorize it, I also forget these things a lot, so I'll share the notes with you. So just keep these notes with you, okay, trust me, after 5 or 10 years you have to open these notes. You have to, after 3 5 years, right, when the kind of technology that we see, and you have to go through these things to understand the concept, to encapsulate, okay, to encapsulate the kind of uh, or to adopt those changes, right? That's why I'm telling you all these things, right? So now over here, the how this whole thing works, the attention. First, general word embedding, general, okay, word embedding, that is your X, okay. Thereafter there would be a linear layer. Now, this linear layer, those people can understand better who actually knows about machine learning. Again, the machine learning process. If you are not so much aware of the machine learning process, you may find it little difficult to understand, right? But if you have a fair understanding of machine learning, you can easily understand. That's why I said each and every technology is quite so much related to each other that now if you have to understand generative agentic AI end to end everything of it, some concept of machine learning is required here. Same way the technology that is going to come in next 2 to 3 years, okay, that will be so much linked with the current technology that without having the understanding of current technology, those understanding of those technology will be little difficult, right? So this thing is very simple concept, okay, but that I used over here. But those who knows machine learning, they can easily, for them it is very easier to understand. For those who don't know, they can relate with like this that I told you. Okay, weight matrix is something that model learns so that it can decide something. Thereafter, the next step is what? We do the dot product. Okay, dot product between what? Between the Q, okay, and this guy, right? Q means what? Q means Q will take of any single word, okay, and K will take of each word one by one, okay. We take Q over here, K of transformer, K of R, K of amazing, one by one. So this will give me what? A score matrix, okay. Next we do what? We scale it, okay. Then we apply softmax, okay. Then we just get the over here attention weights, okay, attention weights. Okay, what is attention weights? That we get it over here like this, 0.41, 0.27, 0.32, something like this. Thereafter, we take our attention weights, okay, multiplied by V vector, okay, and then that will give you the new contextual vector. This vector is actually know about the context of a particular word, okay. So this value, when we get the context, obviously, if I give one sentence, wrong context will be derived, but multiple sentence, multiple text data, huge amount of text data when we provide, this process will just update itself. And at the end, we will get the best value of W or the weights, which will give me the best value of this particular thing, right? So here, each word actually understand the others, okay, even a particular word which is very far in the sentence, okay, like see if I write over here sky is looking, okay, just a minute, let me write it somewhere else, okay, here sky is looking beautiful, okay, and it's blue. Okay, so here is the sky in blue. That means very far. But still, you know, here sky understands that, for the it understands, okay, the vector of sky, okay, the contextual vector of sky that that is already present, okay, that is being identified, that is being created using huge amount of data. Okay, this contextual vector of this sky, that is sky, it it is having the information about the blue. Okay, this vector actually know that blue is an important thing for sky. Okay, so even that's why, in the text, even if blue is present, like you had given this particular text, okay, you had given this particular text to your model, and you are asking about it, or you are asking that, okay, anything about it, right? So, or you just say that you just given over a sky is looking beautiful and it's now blank. Now, when you give this particular information to the model, how can it give you the blue, the next word blue? Because the context vector of sky, okay, it knows that what are all the important words for the sky. Okay, this guy actually knows that what are all important words for the sky. Okay, so out of all the important words for the sky, okay, like cloud, blue, having rainbow, right, it will just give you one of the word. Okay, because here it knows. So here each word actually understand others, even it is far in the sentence. Here, like, unlike in RNN, here there is no left to right limitations. Okay, it's not like that only things will work from left to right or right to left. No. Okay, it is like anywhere words are there, it will identify its importance, and everything is parallel over here. Okay, there is no sequential thing. Since everything, all the processing is parallel, this is very fast compared to RNN. Okay, now we can add over here multi heads, okay, to learn different parameters at the same time. Okay, what we can do, we can add over here multi heads. Now, what is multi head? Okay, so let's say multi head is what, like, you can consider it like that. If there is a particular word, right, so that word can, for that word, models would also try to learn the relationship based on different factors. What should I how can I explain it? It is basically a kind of a relate, like, relation to grammar, okay, the grammar about a word, okay, like positioning about the word, okay, conference. So there are so many other factors when it will try to learn. That is called multi-head. Multi-head I'll explain in detail for you. Multi-head attention, okay, self attention, we know, we need to understand what is multi-head attention, what is feed forward, these things. So I'll explain that, but again, that is again some theory. So I want that we should get engaged with some hands-on, okay, so that there'll be a little kind of hands-on we do, and then again we'll get back to the this particular thing. Okay, so that interest will keep, like, otherwise it's so much theory will be there, then it will get over, right? So we'll just have a hands-on. So what we do, I will use over here the library called transformers. Okay, so in the transformers, actually, let's see, transformers. Okay, transformers library. Okay, so so transformers library actually we access from Hugging Face. Okay, through transformers library, actually you can access a lot of large language model. Okay, you can access Llama, you can access, these are TZA, so many language models are there, and we can also access GPT-2. GPT-3 is paid, right? GPT-4 is paid, but GPT-2 is free. Okay, so we can access that, right? So I'll just tell you today, like, how can we do that? Okay, so first we have to install this thing, okay, in our system, right? Pip install transformers. Okay, for GPU acceleration you can use it, but if the CPU, you have to install this thing, right? If you are using PyTorch and all, like to install CPU only version of transformer and machine learning framework, run the following command. Let's say for the TensorFlow, we have to use this thing. Okay, for this is Apple, for Apple one, this is for TensorFlow. This is for TensorFlow 2.0. Okay, so it's like, if I have to install, see, I have installed this thing, okay, and it is working for me. Okay, now it is working for me because I have the GPU in my system. I have the NVIDIA GPU, so that's why it worked for me. Okay, in case if you don't have the NVIDIA GPU, or sorry, if you don't have any GPU, okay, so in that case, like for example, run the command below to check if your system detects NVIDIA GPU. So I'll show you. Let me just run command prompt. Okay, and in this command prompt I'll just keep this command. Okay, NVIDIA SMI. So as I said, like I have the NVIDIA GPU, right? So that's why it just recognizes it. Okay, so in your case, if you have the NVIDIA GPU, it's fine. Okay, if it is not there, we have a solution for that. Okay, suppose if GPU is not there, so only the integrated Intel GPU is there. So in for that Intel GPU will not be enough. Okay, will not be enough to use this transformer. It is very huge. So they created this thing. Okay, CPU version. Okay, they created this CPU version. Okay, so using this CPU version, we can install it. But for that, we also require TensorFlow. Okay, in our system, right? So it's like if you can, use this tensor. If you have installed TensorFlow in your system, now how to install TensorFlow? Very simple. Okay, install TensorFlow. First, TensorFlow should be installed. TensorFlow is a framework of Google, right? So to install TensorFlow, it is like Python M. No, this is not. This one is just creating the environment. Here, pip install TensorFlow, right? Using this command, actually, we can install the TensorFlow CPU. Using this command, we can install the TensorFlow GPU. Okay. If I have just CPU, first we'll run this command. Okay. I'll just write it in the command notepad. Just a minute. Okay. Hmm. Okay. So first we have to install TensorFlow. I'm telling you for the CPU. In case if you have GPU, we can do it. Okay. So for step one, okay, install TensorFlow. Why are we doing it? So that we can use uh transformer. Okay, we can use okay, we can use transformer for some generation task. Okay, like we will use transformer for image generation, text generation, so many things. Okay, you generate image through GPT and all. I'll show you. You can generate image free of cost, right? That also I'll show you. Okay, through transformer, right? So step one is what? Install the TensorFlow. For installing TensorFlow, we have the command over here. Pip install TensorFlow. This is for the CPU. Okay, and this is for GPU. Okay, so in case if you have GPU, you can use it. Otherwise, you can just use CPU one. Okay, now once the TensorFlow is installed, then we have to install this guy. Okay, this is what for the CPU. Okay, this is for CPU. Okay, only now it is two lines are there. Both we have to do no. We can use just this one. If this is not working, then you can use this one. Okay, both are not required. Right. Now, in case if suppose my system is slow, okay, I have suppose 8 GB of RAM, my CPU is not having, I don't have that much space in all. Okay, so these things suppose it's not working in my system, right? So what we do? Install transform. So in that case, we don't have to worry about it. We can go to collab. Okay, because on the collab, we can access everything. Like you can access GPU and all, right? So when I go to collab, so this is what we do for offline. Offline means what? Offline Python. Okay, like Python in my own system. Okay, or like Jupyter notebook. Okay, if I want to use Jupyter notebook in my system, we use it. But Collab, when I open, if you see over here, I'll connect it, right? Here, I'll show you. It will be connected. Here, when I click on this arrow, right? Change runtime type. Okay. So I'll change the runtime type over here, and then I can access GPU over here. Right. So in case I don't have the GPU and all, nothing to worry. I can go to Collab, and at the Collab, I can access the GPU free of cost. Okay, for each session. Okay. No need to access premium GPU. It's like normal GPU is fine. Right. Now what we do first, I have to install TensorFlow. Sorry, TensorFlow is already there because TensorFlow is a Google product and Collab is also a Google product. So TensorFlow is by default there. No need to do with install TensorFlow. Just we will do what? We will install this guy. PIP install transformers. Okay. Only this much I'll do. Okay. So I'll execute it. So it will just install. It is saying what requirement already satisfied. Okay. That means Colab is already built with the transformers. Okay. This library is already there. Right. Now what we do? We are going to use it for the text classification using BERT. Okay, we are going to use text classification using BERT. Now what is BERT? BERT is basically a encoder based transformer. Okay, but if I search bidirectional encoder representation for transformer, this is a encoder based transformer. Okay, all the models are not using encoder and decoder both. Okay, I told you in last class that transformer contains what? Encoder and decoder. Okay, transformer contain encoder and decoder. But all the model don't use encoder and decoder both. Okay, there are few models which uses both encoder and decoder, but BERT uses only this part, encoder part. Okay, BERT is just used for encoder part. Right. That's why BERT can be used for text classification or sentiment analysis kind of thing. Okay, BERT will not be used for generation. Okay, BERT is something which is not used for any generation. It can't generate. Okay, it can just classify. Okay, GPT is only using decoder part. GPT don't use encoder part. GPT is just decoder. Okay, GPT is not encoder. GPT is what? Using only the decoder part of it. Just keep in mind. Okay, now you may be thinking, okay, fine. So here GPT is using only this much, right? So GPT is what? Decoder based. Okay. Now you may be thinking, if it is a decoder base, then how it actually kind of do the translation and all, right? See, the initial model of GPT, okay, was not doing the translation, because for the translation you required encoder decoder both, right? Okay. Like suppose you have to do the translation, so it's like I am learning Python. Right. So in this one I have to translate. So encoder will take this information and decoder will translate into some other language. Okay. मैं Python okay सीख रहा हूँ, something like that. Right. So it's like here we can decoder encoder both. But how GPT is translating nowadays? GPT can translate. So now GPT now improved, but still it is using decoder only architecture. But now with the kind of data using which it has been trained, that it knows different language. That means if you give anything to translate to this guy, it just generate the first word, okay, then decode and generate the second word, then third word, then fourth word. Okay, that's how it works. Only with the help of decoder it is generating. I'll show you, I'll explain you that part. No worry, I'll explain in detail. But as of now, just keep in mind one thing, that whenever there is a LLM model, it is not necessary that it is using both encoder and decoder together. Okay, like we are going to use first BERT. Okay, so BERT just uses the encoder architecture, right? So how can we use BERT? See, when you go over here, you go to quick start, right? In the quick start, here it's if I let's scroll down, mm, not this one. Just a minute. Here it is something different. I have to use model, right? Base in it, training, quantization, resources. Just a minute. Transformer. Here is the models, right? Okay. So I'll just click at the models over here. Okay. Let me just click at the models. Okay. So when I click on the models, I'll get so many models that are present over that we can use. Right. Here I can just choose like text generation, image to text, image to image, text to image, what I want to do. Okay. Here I can choose the size of model. Okay. That means now it is a small size model. Okay. Here it's like large size model, right? I can just use it. Okay. I can use the model which one is using like PyTorch based, like a model which is using PyTorch library, a model which is using TensorFlow library, a model which is using diffusers library. Diffusers are used for image generation. Okay. The model which is using transformer inbuilt library, Keras library. So many, things that I can set. Okay, like when you buy a product from online, so we set the filter. Here also you can set the filter, right? So let's say here I have a model. I want to use, let's say, GPT. So I'll just search for GPT over here, right? So when I search for GPT, I get only one option, GPT-2. Okay, using this, you can also use Llama. You can use so many models. I'll show you, right? So it's like when I click here, I scroll it down. Okay, here I'll get the option that what you want. Okay, so you don't have to kind of memorize the code. What I told you earlier, when we go to the generative AI part, you don't have to memorize the code. Everything is documented. You just need to know how to read those documents. That's it. Okay, so let's say I'll just copy this thing from here. Okay, all right. So, sorry, I am trying to use over here BERT, right? GPT I'll use later on. First of all, let's start with the BERTs. I'm sorry, I just moved to GPT. If I'll just search BERT over here, okay. So Google BERT or something I'm getting, okay. BERT based uncast. Okay, so let me just open it. Okay, I'll scroll down. Okay, so here it's like I have to pick this thing, pipeline. Okay, and then first I'll just import it. Always this line I have to use. So I'll copy this thing and I'll paste it over here. Okay, now what I want to do, I want to use it for some uh, categorization or some sort of text classification, right? So for the text classification, okay, I have to check because here it is mentioned. This is for the fill mask. Okay, fill mask is what? If I will give over here a blank, okay, so this is fill mask. Whenever you see it is like kind of a fill in the blanks. Okay, fill in the blanks thing, right? That is what fill mask. Okay, so I have to use it for what? For the text classification, right? So you can just check over here. Just a minute. Here it's like we have to use it for sentiment analysis, right? So search over here, sentiment analysis, bot based multi-language. So here it is a sentiment analysis, right? When I search it, so much documentation are there, it's very difficult. Okay, so when I just search it, are we getting any code over here? Okay, so here I'm not getting any code. I should get the code over here. Okay, use this model. If I click here and I'll click over trans, but it's like asking for the API. Just a minute. Let me just give a text classification over here. I like transformers. Compute. I have just given it. I'm just checking it, right? So it's like it is just computing that sentiment. So, but anyway, here it's not showing me actual code. Okay, it may be over here. It is not showing, no problem. You see, if I click it, okay, it will just open some of the code, but those code we can't use directly. Okay, if I click it, it will open up a code. Those code we can't use directly. You can try this thing. I'll also tell you this process. It will ask you the API. So how to give API and all, that is a next thing that I'll tell you. As of now, I just want to make the thing very simple. Let's say I have to just use the text classification. So after the pipeline, here we have to do what? Pipeline I have to call, this particular class I have to call. Okay. And here I have to give what I want to do. Okay. Let's say sentiment analysis. Sentiment analysis. Only this much. Okay. No need to give anything extra. Right. Because, now why it is not present? Because they had, modified this document so much. Okay. Earlier, it was not that messy. Okay, it was very simple and easy. So that's why at that time I had used. So I know that these are the basic code that is still it work. Okay, they may have removed this thing from their website or something, some more, kind of a complex thing they have added. But it's fine. This also works. So here I'll just use it over here, pipeline, and then I'll use classifier physical this thing, right? Now I'll just execute it. Okay. So when I execute it, what it will do, I'll show you. First of all, it will just try to access the model properly. So let it be done. Meanwhile, when it is accessing the models, okay, uh, okay, it is accessing the model. Okay, so now it is accessing the model information. Okay, so whatever the model that is required, okay, JSON file, some, like every model is having some sort of artifacts. Okay, so it just access those artifacts, right? Now I'll define a text that this guy can use. Okay, so text is equals to, let's say, I like transformers. Transformers. Okay, thereafter, sometimes machine models behaves terrible. Okay, so it's like it is what we did. Okay, some text I have defined. Okay, now I'll do what? I'll just pass this text through the classifier that we have. This is object. Okay, so this object I'll take and I'll feed the text over here. Right. So when I feed it, you can see it just identified it as a positive 0.9 and it's a negative. Okay, so very simple. It just identified it. Right. So we can do what? We can also kind of run this thing and can run a loop. Okay, like I can just store this thing into results. Okay, and I can run a loop that can do the thing. This is our first, you know it's a kind of a hello world program. Okay, it's just hello world kind of program, very simple program. Okay, hello world, right? So it's like we did what? This is a process we have to use every time. Every time we have to import this thing. When we import this thing, thereafter you have to define over here the purpose, like why I want to use it, like sentiment analysis, translation, text generation, whatever, right? So I have to just define over here purpose, and comma I have to define over here model. Here I'm not defining model. Okay, it is saying a comma model optional. Okay, so if I don't give the model, I guess by default it uses board. Okay, if I don't give any model, it is just, maybe it is just using the word. But yeah, we are very soon we are going to define the model as well. But before I move ahead, if you are doing, please just check in your system if this is working or not. Okay, if this will work, then I'll be sure that whatever that we are going to next, like translation or text summarization or text generation, those will also work for you. Is it working? Just confirm. First, you have to install transformers. Second, you have to just kind of define a pipeline for sentiment analysis. Third, we are just passing the text. Okay. Is it working for anyone? Meanwhile, I'll also share the file with you so that you can access it.
We will try later after the class of tomorrow morning.
Yeah, it's fine, no problem. But please do try, right? Because this is quite system dependent. Sometimes it don't work. So if it is not working, we have to fix that. Right.
Sure,
So
sure.
now, right. So now let's say we did this thing, right? Now let's say I'll do what I'll use for let's say second application that we use over here is for machine translation. Okay, translation. Okay, so for the machine translation, what we require, this thing will remain as it is. Okay, I'll just copy this thing. Okay, paste it over here. Okay, I'll make the change over here. Okay, let's say it's a classifier. Let it be translator. Translator. Okay, and here I have to give translator like what I want to do. So I'll again go back over here and I'll just search for, let's say, translator. Okay, translator. Translate LATION. Okay. So when I just tried for translate, so we are getting these kind of, no, this one I don't have to use. Okay. Just a minute. It's translation. LATION. Okay. So here, if I'll check, these are the things that are there, but it's not showing me what I want. We have a models backyard. It's like it. I just want to show you like GPT-2 is also used for the translation. Okay, let me try with okay, translation. Okay, translation underscore English to Hindi. Okay, so here if you see translation, some of the models that we get. Okay, you can just check which model you want to use. Okay, like suppose I just take this thing, but this I'm not, so this I don't trust more. This Helsinki is good. Okay, Helsinki model is there that I had used, that is good actually. Okay, English to French, English to TR is what? You can just check what is TR. Okay, so Helsinki also I had used, right? So it's like GPT-2 also I had used. Let me try with GPT-2. Okay, so GPT-2 it's something that we will use. So if I have to use the translator, okay, these things also you can use. These are already given, text generation and all. So here I have to write, okay, translation, let I went translation English to Hindi. Okay, and then here I have to give the model name. So model is equals to, let's say, GPT-2. Okay, and then I will just check like whether it is working or not. Right. So output, in case if it will not work, I have to use some other model, right? So let's say output is equals to translator. Okay, and I'll give it a things like roses are red and sky is blue. Okay, and then I'll just print the output. So this will be the heavy model. I should use it separately actually. I should not write over here. But anyway, I already wrote. So do it over. Okay. So as I said, let's say this one that I did. Okay, now here it is saying a GPT-2 model is not, so at that time, this particular thing, roses are red, sky is blue. So it just tried to complete the sentence. Okay, as I said, like initially, GPT was not a good translator. Okay, it is a decoder model. Okay, it could not translate actually, right? It is just a decoder model. So it can do these kind of things. Text generation. Okay, like see, if I'll use it, text generation, here I'll use text generation, right? And thereafter, if I will use this thing, then it will work because it's a, sorry, I just give text generation. N-E-R-A-T-I-O-N. So here, now I'll do what? Roses are red and this one, it will generate. Okay, that means it will just generate the next number of words. Okay, roses are red, the sky is blue, the wind is blowing across the whole city, and its streets are lined up in the middle with the number. So, see, you can see, because translator requires what? Translator actually requires encoder, decoder both. One guy will encode, other will decode, right? So that kind of thing. So here GPT-2 was not, a kind of a, it was kind of a, just a decoder thing. So decoder can do what? Can just generate, right? Based on the information that you give, okay, it will generate the next word, then next word, then next word. It can only decode. Decoder means what? Just generate, right? Like we had created RNN. So in the RNN, what happened? It was just generating something, okay, one by one next word, right? So that's why it is just generating, right? Here we can do what? Here we can just set the max. It is what? Unlimitedly it is generating, right? Just keep generating, right? So I can do what? I can just give it a maximum length, let's say is equals to 20, okay, right? Like this. Now here the maximum length is what? 20 over here, but still it is going very long. It is not picking up my length. Okay, so 20 it took, that's why it is stopped over here, meaningless, something like that. But anyway, 20, I don't know how it is calculating 20. Is it 20 sentence it has generated or what? It has generated 20 sentence, I guess. Anyway, so now over here, the output is generated in a list over here. So I have to give what? Index 0, right? So when I give index 0, now I will get only the dictionary. So from this dictionary, I can take this key. Okay, I can just take this key over here, right? So whatever key that we take, okay, here let's say it will be 10. Okay, so now the output will be only the text. Okay, roses are red, sky is blue, and the sky is, I don't know how when the sky becomes green. Now the light in the sky is red and something like this. So it has generated over here, I guess, 10 sequences. Okay, so let it be maximum length 2. Okay, so here it is, roses are red and the sky is blue and the two-way audio link to the right. So something like, something randomly it is just generating. Okay, it is not sometimes meaningful, sometimes meaningless, but yeah, it is giving you some output, right? So this is what only the decoder thing. Encoder is something which is doing this thing, decoder which is generating the next thing. All right. Now translator, for using the translator, there is some model called Helsinki. Okay, I'll show you. Um, Here, why can't you use GPT-3? Because GPT-3 I can't use from Hugging Face. Okay, GPT-3 or 4 is not free. So for using GPT, I'll show you how to use GPT-3, GPT-4. But for that, we need a API. Okay, we need a API from the OpenAI. If I want to use GPT-3 or GPT-4, I need the API from the OpenAI. Okay, here it is, NLP, Helsinki NLP, this one. Okay, so Helsinki NLP is there. You can see translation over here showing, right? Translation. This is for generation, right? So this is a good model. Okay, Helsinki NLP, right? So here, whatever the translation you want to do, okay, here it is like empty Jane Ian. It's like empty maybe some language. Okay, I'm not sure which language it is basically. Empty is fine. Empty is just empty. It's like JA maybe language, Japanese to English. It may be Japanese to English. Okay, it is maybe Japanese to English, right? So here I'll copy this thing. Okay, first of all, let me write it over here. Third that we are going to use over here, machine translation. Okay, so for that I have to import this thing as it is. I'll just import this thing over here as it is. Okay, now I'll go over here. I'll take this model and I'll define it over here. Now Japanese I don't know. I'll use that I know actually. You can check EN. EN is for English, and for Hindi it is actually HI. MTENHI. Okay, and then here I will write that what to do. Okay, so where I have to write it over here. Let's see, is it some code is given or not? They have not given any code. Opus test translation test. Here, if I will use this model. So when I click on use this model, and I will click over here transformer. Now it is giving me. Okay, so now it is giving me what that I can use this thing pipeline and this one. Okay, so I'll just copy this thing, right, and I'll just paste it over here, right. Okay, fine. Now what do we do? I'll just use over here. Okay, first let me execute it. It will access the required model, the at the whatever the artifacts required, right. So once it will, again, the process is same every time, right. Now here translator will take dot, no translator, and then I'll feed over here roses are red and sky is blue. Okay, and the output will be there. Okay, I'll just print the output. Okay, right, so it just did it. Okay, now it is doing it. So I'll take the square bracket 0, right? So I'll get only the dictionary, and then I can take over here the key value over here, translation text. Okay, okay, so like this. All right. So it is a good model for the translation. Okay. Now, if suppose I have to summarize, okay, I have a text given, I want to summarize it. Okay. So for the summarization, what can we do? Summarization is something which requires again encoder and decoder both. Right. So for the summarization, we can use a model which is called Google T5. Google T5 is actually using both. Okay. Like, this guy, Bert uses encoder, GPT uses decoder, popular one. Helsinki also uses encoder, decoder both. But, there is one more model, which is also very good model, which is called Google T5. Okay. Now this uses both. Okay, because for the summarization also you need both of them. Okay, so it's like, let's see if I use that. Okay, let's say I'll just write it over here. Fourth, it is a fourth or fifth? Fourth. Okay, so fourth, text summarization. All right, so for the text summarization I want to use T5, right? So I'll go over here. Okay, and I'll search over here for the T5.
But how do we know which use case we need to use which model?
That actually, when you keep working, because there are a lot of models are there. Okay, so there are thousands of models, so I can't define a rule for that. Okay, but yeah, it's like with the kind of experience. Okay, you know that, okay, what are the good models, what are the because always, like, so today suppose you are using a particular model T5. Okay, you find it good, but tomorrow something better can come, right? So that again you have to use and check. right? So there are few good models that I will tell you, but there are thousands of models are there. Okay, so it's like you have to be also keep updating yourself on this particular Hugging Face, or you can just do it like this. Suppose text generation. So you can just click it over here for the text generation, right?
Mhm.
Oh, sorry. So when you click over here text generation, you get all the model which are for the text generation, right? Thereafter any to any. Okay, that means any input, any output, multi-model. That means you can give image, text, anything. Image to text. So these are all the model for generating the image to text. Okay. Image, text to text. That means this is multi-model. That means you are giving image as well as text as a input. Only image to text. Okay. So like you will using this model, you can give the image, and this model will just kind of explain your image. Okay. Image to image. Okay. From one image, it will just generate some other image. This is very good model, Black Forest. But this its size is too big. I had used this Black Forest actually. It generates a very, it also actually generates the image. Flux 1 point. There are so many, websites are there who charge you for the image generation. Okay, they are using this model a lot. Okay, they are using it free, but they charge you. How to create such website? I'll tell you. Okay, if you want to create such website for image generation, I'll tell you. Text to image. These are the model which, as I said, you can say Black Forest. Okay, Black Forest, this one. This is used for text to image. Okay. So now how to use it? If you open this thing up, right here, it is mentioned. Okay. Using this, we can use it. Right. So, or we can also use it, use this model. Here it is a diffusers. So when I click it, you can see, right? So if I will run this thing, it will generate, but anyway, I'll come to it. Okay, first of all, let's do other thing. Thereafter, we'll use it. Even if you try to use it, you can just copy this thing and can use it. Right. So it's like, now over here, text to video. Okay, some models are there that is generating text to video, text to speech. Then it is, plus 42. Okay, it's like so many different options are there. Text classification, okay, text to speech, okay, natural language process. So from here you can actually check, okay, and whatever you are getting over here, you can just try those. Is it fine? Okay.
But how,
So
yeah, how to choose the correct model, like based on the use case we have to select.
mhm.
So
See,
yeah, so many model. Yeah.
choose. How can you choose? It's like, like how you buy a product based on the rating and all,
Yeah.
right? So
Yeah.
same way, if
Yeah.
you see over here, it's like 315 people liked it.
Yeah.
Okay,
Yeah.
300, 3,000 people downloaded it, right?
Okay.
So it's like, based on this, we can say that, okay, this particular model for text classification may be a good model. That's why so
Okay.
many people are liking it. Okay.
Okay.
Now this one
Okay.
also, like 2.69 million downloads.
Yeah.
Okay. Downloads means what, because these model actually you can download into your system and use it offline.
Mm, mm,
Okay, but again, your
mm,
system should have that much space. Some model requires GPU, right? So
mm,
that's why, but
mm.
depends upon that thing. And 790
Okay.
people liked it, right? So
Okay.
I can click here and here use this model and here transformer. So here code I'll get, okay, and I can
Mm,
use it for that purpose.
okay. Okay. Got
Right. So these are
it.
the ways generally because there is no fixed set of rule. Like it's not like that, there is some formula using which you can calculate. Okay.
Mm,
It just, which model is good, which one is working better. First of all, you will most of the thing will learn from with the help of experience, like when you use it, right?
mm, mm,
But
mm.
initial filtering, you can do it like this. Okay,
Okay.
based upon how many people liked it, or because these are kind of, or these models are globally getting used. Okay, so
Mm,
many kind of a company, so many organizations, they are using it, right?
mm, mm,
So if someone is using this model and they liked it, okay,
mm.
so where to like, there is any option of liking? I can't see. So how they are liking it. So there may be some option, like it may be like you are using it, just a minute,
Correct.
transfer. Is there any option to like? Okay, here it is option, right?
Correct.
Okay, so it's a like, if you use it, you get a good result. So it's like you can just like it, right? So like that. So there are thousands, millions of people are using it. So some people, some organization may find it good, so they are using it. You can create this Hugging Face account actually. Okay, like this Hugging Face account is very important. Okay, this Hugging Face account, if you create here, from here I'll show you a lot of different model that you can access and use it. Okay, like as of now I was telling you about the this one that is called Google T5. Okay, or suppose I have to use for the summarization, right? So for the summarization, what I can do, filter task by name. Let's say I'll just use over, I'll write summarization. Okay, so that is text summarization. So for the text summarization, these are the models we have. Okay, so it's like Facebook, BART, large CNN. Thereafter this one, so many actually came. Okay, here is T5 based. I want to use actually Google T5. I can use other as well, but those other I will use when I'm not taking the session. As of now I'll use that one that I have used earlier, and that has given me a very stable result. Okay, because class is not for doing the research, right? So that's why I'll use it. Okay, later after the class, I can try others as well. So if I will click it here, okay, now it is saying me how to use it. So this is how I can use it. But why it is showing war is 01? It should show me Google only. And they removed it or what? They are so doing so much update actually. Um, it should show me Google T5. Just a minute. T5 base. It is T5 base I can see, but I can't see directly from the Google. I can see from the third party. I just don't want to use from the third party. Yeah, here it is. Google Flat T5. Okay. So if I click it, use this model transformer. Okay. So it is no auto tokenizer and other things are coming over here. Why this thing changes? So that code also, the code that it is showing, that code also we can try. But first of all, let's try with the code that I had used earlier, and that worked, because these things keep changing. Okay, keep updating. Whatever code that you use today, you may find something it changed tomorrow, right? But what I had used earlier, I'll first try that. If that will not work, then I'll use it. Okay. So let me just try that what I had used earlier. First this one. Next, here we'll define let's say summary I want. So for the summary is equals to pipeline dot summarizer. Okay, or I can just use over a pipeline. All right, so pipeline what, and I want it to be summarized. Right, so I'll just use over here summarization. SUMMARIZATION, summarization, right? And thereafter I will use model is equals to, first I'll try the model that I had used earlier. Maybe because of some update, something has been changed, but I just want to check whether that is working or not. Okay, if it will not work, then I will use as per the documentation. Okay, now I will just execute it. Yeah, it is accessing it. Then why it is not showing here? Let me check once. Google T5, I guess they hide it or something. T5 efficient, or maybe have been updated it. Okay, here it is, right? Google T5 base. Okay, so you can click here, use this model transformer. So this is what I'm trying to use. Okay, so it is there. It's a kind of a very much crowded, right? You'll see lot of things are there, right? Lot of things are there. So now how do I know that I have to use it? See, when I was started using it, at that time it was not that crowded. Okay, it was not having that many options, because too much options also create a lot of chaos. So now it is actually creating a chaos. So at that time we were not having that much option. It was having a very few options. So out of those few options, we used to we you can easily find out and use it, right? But now they had added so much options that it's we have to do filtering over here, and based on the filtering we can use someone good, right? So as of now I'll use it. Okay, you can try with some other model as well, right? Now what I do, I need a text. So let me just copy this text, any text I can use. Okay, so let's say for the summarization I'll take this text over here. I'll copy this text. Let me check like if this text is okay, and here I will define the text. So I have to define the multi-line text. So here it is like this. Okay, let's say triple quotes in Python is used for multi-line text. All right. So this is a text that I want to summarize, right? So object is already defined over here, summary. This is encoder-decoder architecture. T5, just keep in mind, it is an encoder-decoder architecture. Okay, let me write it over here. This is encoder-decoder. This is transformer encoder. It is having encoder as well as decoder. Okay. This guy is having also encoder as well as decoder. That translation it is doing, right? Okay. This guy is just decoder. Okay. This guy is just decoder. Okay. This guy is what? Just encoder. Okay. But is by default is just encoder. All right. So now what I do, I'll take this thing that is summary. Okay. And summary, I'll take it over here, and I just feed the text. Okay, so for that, let's say summary, and here I feed the text over here. Okay, then I will define maximum length. Okay, maximum length, maximum length I want it to be, let's say 30. Okay, and minimum length, let's say 10. Okay, and this one I will store as a output. Okay, then I can just print the output. Okay. So it has given me some output over here, but actual output present over here. Okay. So what I do, I'll take over here index 0 and then this key value. Okay. This key value I'll take summary text. Okay. Oh, what happened? It is showing invalid syntax. What else? You forgot comma. Where I'm missing comma? Just a minute. Okay. And here, okay, fine. Key value, it should be what I'm doing. This should be square bracket, right? Okay. So I'm not getting it. This is how I get it, right? Text to what happened? This guy is not working. Maximum tokens. So maximum length and minimum length we set. Maximum length, minimum length we set. Then why it is not giving me the summary text? Just a minute. The output we are getting it over here. But okay, summary underscore text is there. Okay, fine. That is what the problem. I was not giving this underscore. Okay, so it's like no happened. Oh, here is output. Okay, let me use over here little bit more length. Let's say 50. So this is something we're getting, right? So let's say our text to text, this one. So this is actual output, right? Like, okay, let me just compare it. Yeah, this is output. Our text to text framework allows us to use the same model, loss function and hyperparameter on any NLP task. So whatever that we had given over here, it is being summarized it over here. All right. So it's like this information also, it is giving this information we don't want over here, right? But it is giving it over here. Okay. One more thing. Okay. So see, every time it is giving me the same output, right? So what I do over here, I'll just use something called do sample. Okay, is equals to false. Same thing I'm getting. That's do sample is equals to, by default used to be true. Okay, so when it is true, you can see what it is doing. Okay, we propose refraining all the we out. So every time this output is different. Okay, when the sample is true, that means it is just taking different samples. Okay, just creating a different samples, and from that sample, it is giving me one of that. Right? So that is what. But if I will use do sample is equals to false, it will give me the same output every time. Okay, this will not change. Right? So this is working good. Only have to do what? I will just put it over here. Let's say summary. Okay, right. So I'm getting the output. That is okay. This thing should not be present. I guess this is coming only over here. This will not go. This is just kind of a default thing, but when we create any UI, this will not be there. So both maximum token and maximum length seem to have said maximum new token will be, they will take precedence. Please defer to dog. But something, some information it is showing over here. But the thing is, I don't want it, but it is still showing. Let me just check some parameter through which I can ignore it. Generally not so. It is showing for the first time. I'm not Apple T5. When I put comma and just put the cursor, it is showing that what you can do. So it is, these are the two more parameters that I can try, like tokenization. So what is tokenization? Okay, tokenization is like tokenization is like converting the text into word. Okay, so here for the tokenization, it will use the same T5 model, right? So here I can just copy and I'll just paste it over here. Okay, in the pipeline also we can paste. There is a pipeline. Okay, here also we can paste it. Okay, so for the tokenizer, it will use the same thing. What happened? Summarization, tokenizer, framework, what it is doing, error it is giving. Keyword argument not understood. I thought like it should be given over here. But anyway, let me just take this thing. And here I'll give it. But here why I'm giving it, just a minute. See, when I use this thing, actually we have to give tokenizer in the pipeline only. Okay, here I can't give it. Sorry. I have to use it in the pipeline only. Okay, so here it's fine, but here I can use in the pipeline. That means some other mistakes we are doing. It is not about it, right? So when I give it, keyword argument not understand towards D type. So this error we are getting, why are we getting this error? Is it like my GPU is, TPU is connected? Then why it is giving me this error? Just a minute. GPU is connected, then this should not give me this particular error. These kind of challenge you face. Okay, like I just copied the code as it is, but still you can see I'm getting error. Now I just remove that TF. Okay, TF was for TensorFlow, so I had seen some error was there because of these are very unstable technology. So now we are getting it. So this is just optional. In case if you want to use tokenizer, you can use it. Tokenizer is like converting the text into tokens so that better processing happens. Okay. Now it's like maximum new tokens or something it is asking that I had given over here. But still these guys are coming. I don't want these guys, but still it is showing over here. Maybe it is a default. Actual output is over here. Okay. What you can do, you can, just use it separately. Right. This one. Okay. Because this is showing because of this thing. Right. Actual output, you can show it over here. Right. That is your actual output. So as this is not the output that will be there if you create any UI, so that's fine. You can ignore that. Now for the summarization, actually we can use something more. There is, Facebook is also having a model. Okay, I'll show you. For the summarization, I had also used earlier Facebook. So it's like I keep trying different one, right? Because I have lot of options are there. Okay, like if I will go over here, I have a lot of options. So summarization, I'll also suggest you to try them. Okay, so here it's a Facebook BART large CNN. Okay, this one also I have used earlier. So I'll just go here, transformer and copy this code. Nothing to do, just copy this code. Okay, and I'll get back here. Okay, so now it is like Facebook but large CNN. Okay, so if this one also I can use for the summarization. So let's do this and check the output. It is 1.63 GB. Okay. All right. Now what do you do? I'll just use it over here. Just copy this thing. Okay, and paste it over here. Right. So our text, okay, pipeline is also defined. I just have to define the summary. That means this summary, right? So what is summary? Summary is something that we have to define over here. Summary will be equals to what? Here, what I should do, we have already pipeline summarization is defined. So summary is equal to, here it should be, let's say summarizer. SUMMARIZDL. Okay. So this is a summarizer defined. Okay. I just copied it, right? Now in this summarizer, okay, when I have defined the summarizer, in this summarizer, what we have to feed? We have to feed the text. Okay. Summarizer is defined. Just feed the text over here. Okay. We will feed the text. Along with the text, what we feed? Same thing. The maximum length, minimum length kind of thing. Right? Do sample kind of thing, right? So we define the object summarizer. In that summarizer, we define what? The purpose and the name of model. And then what kind of summary we want, right? So now this will give you the summary. And this summary, this is actual output, right? So how do we, so once we run it, it will create the summary, right? I can just print over here, or we had used earlier output. So let me use output, otherwise you'll get confused. Okay. So let's say output. Now output, if I print it, I get it like this. Thereafter, I can take index 0, right? And thereafter, I can take what? Summarize text. So now I have two models and we use two models for the summarization. Now we can check which one is good, right? So as you asked me, how do we decide? This is how actually we decide, by using them, right? Like when I use Google T5, so it is saying our text to text framework allows us to use the same model, loss function and hyperparameter on any NLP task. Okay. But when I use this guy, So it is saying what with T5 we propose refraining all the NLP tasks into unified text-to-text format. This is an contrast bot style model that can only be something like that, right? So this seems to be more better, right? You can just try with more and more kind of a text. Let me just try with this particular text, which we can understand better, right? So let's try with this text. Okay, here we are using what Facebook one, right? So let's say like this. Okay. Now if I use it, okay, it is just summarizing the whole text that I had given to it. Nice. Same thing. Let me just try with the same thing with the T5. So here I'll put the text. Oh, what happened? Okay, I guess I have to define it. All right, now it is done. So it is also summarizing, right? So we have two summary. Okay, you can check. It is Google's BERT is powerful language model developed in 2018. So it is designed to improve how computer understand and process. So this is also giving us a good result, right? So we have two models and both are over here is giving me the good results. Not like that one is giving good, other is not giving good. But it depends. Like it is a very small data we are using. Okay. You also have to check on the large data. Okay. But my purpose over here just to tell you how can we use different model. Very simple. Whichever model you have to try and test, you will just go over here. Okay. The thing that you have to check like what you want to do, right? Like for example, let's say I want to work on kind of I don't want to use image to text right now because image to text is like here. Okay, I'll show you why. Okay, let's say if I try to use it, okay, this one, okay, and I'll take it over here. Will it work? See, it requires diffusers. Okay, again I have to install the diffusers. Okay, directly diffusers. If I do it, it will just you can see over here. Okay, my already RAM is getting used more. Now it is saying me then error. What error is it showing? Cannot access this one. Access to model Black Forest is restricted. Okay, so you can't access all the models. This access is restricted. Right? Now how to work on it? To access this, okay, you have to scroll down over here. Okay, and some option you must get to get the access. How to access this thing? Is it showing something for getting the? Why is it not showing? It will show something for getting the access. Accessibility also available. Conflict diffusers, conflict PIP install diffuser, flux pipeline. Okay, so this is something that you can try. Okay, you can use flux pipeline to run the model. So anyway, that image thing I'll tell you. Don't worry about it. As of now, don't go into that direction. Step by step, we'll do. I'll tell you how to generate the image and all. Okay, as of now, this is what we need to know that from the Hugging Face, how can we use the model for different kind of text pre-processing. All
So
right.
can we,
So work on it.
hello?
Tell me.
Can I get that text keyword also with the code?
Can I get
Keyword, keywords
keywords means what?
means in that paragraph some major sentence is there, like a bird, like a language, like a transformer architecture.
Okay. You're talking about name entity recognition.
Means keyword, right? That in any paper having the abstract, right? In that having the keyword for the paper, that type.
Okay. If like for example, if there is any research paper you are talking about, right?
Right.
So from the research paper, some important keyword that you want to fetch.
Right.
Okay, so yeah, that thing is actually called NER, named entity recognition, something, and where like some important person name, or some kind of important place name, right?
In that,
Or yeah.
the means in that your text, right? A transformer architecture is the word, right? A bird is
Mhm.
in that having the also one more word is that bidirectional approach is the one word.
Right, right, right. It is there. You can, by default, we can do that as well. Okay, see, summarization is not doing it, but by default, that kind of model, if it is there or not, if I guess there is no such model which will only give you directly the keyword. Okay, like over here, if I search it, okay, it's only the summarization we have. Okay,
Okay.
keyword, no, it's not there. So what can we do in such case? But we can do that. What you want, we can do that, but directly we don't have any model dedicated to do that thing. Okay, to do that part we require prompt. Okay, that means we give the prompt. That here we are not giving any prompt. Here we are doing it, just giving summarization to do the summary. We are not giving any prompt that you have to do this. Okay, so now we have to use, if I want to do that, I have to work on the prompt based model. Okay, a model in which I can give the prompt, and that will take my prompt, and based upon my prompt it will respond. All right, so for that we can make use of like GPT-3, or we can use Llama also. Okay, so those things we can do, but for those I'll tell you like how to use Llama, how to use this model directly, not from Hugging Face. Okay, directly there are few models are there, that I'll tell you how to use them, like Llama. Okay, if Llama you want to use, so we can do it. We can just install the Llama into my system, and thereafter we can give the prompt that I'm giving you a paragraph. From that paragraph, I want keyword. So they will just, these models can pick the keyword for you and give the keyword to you. All right. So those kind of exercise we will do. All right. Okay.
People, can you just go back to the Llama screen?
Yeah.
Yeah, just just scroll down once.
Mm-hmm.
Yeah. Vipul,
Mm-hmm.
uh, how many types of llamas are there? I mean, and which one is the one that we should target?
Llama 4 is the latest one. Okay. And
I think there were two Llama 4s in the previous screen.
hmm, yeah, all of them are having basically different number of parameters used to train, right? Like for
Okay.
example, if I use this thing, so Llama 4 Scout, it is 109 billion parameters. Okay,
Mhm.
Llama 4 Maverick is having 400 billion parameters. Okay,
Mhm.
it's just the size. Like different models are having different sizes. Okay, like how
Mhm.
many parameters are used, and some are lightweight, some are heavyweight. Okay, so it's 3.2, 3.1, 3.3. I'll show you how many llama is there. I'll go to Llama website. Okay,
Mhm.
and here I'll go to models. Okay, and then I'll go to llama 3.1. Okay, view. So you can see these many 3.1 we have these many versions. Okay, just in 3.1.
Okay.
Okay, so in just in you can see the largest one is 812 GB,
Oh.
right? So this is 3.1. Same story is for 3.2 kind of thing. Let's say 3.1. I hit see show you 3.2. Okay, so for 3.2, if I'll access, these are the difference in 3.2. Okay, so in this there are different features are there. Largest one is 6.4 GB. It is little lighter. Instruct is something which is base one. Okay, it works free actually. Like actually all llama works free, but instruct is something which is kind of which is being created for quick response, and it is being created in a way that it is lightweight, little lightweight,
Right.
and these are little heavy. So some modifications they did and they created it. So these are the different llama models that we have. But they had launched a few more Llama 4, but as of now, Llama 4, is like you have to request the access over here. So you can access Llama in two ways. You can access the Llama directly from their website, Okay, from here you can see, and I click on download model. So now I have to give the details. Okay, and then they will help me download the model. Okay, so like suppose I just click over here, this model will get downloaded into my system. Okay, I'll give the name and also name, last name, email ID. After that, they will send me the link on the mail itself. Okay, it's not like that you give and you download all of a sudden. Okay, when you give all these details, thereafter it will take around maybe 6 hour, 12 hour, 24 hour kind of time, and they will send you the mail that okay, your request is approved. Okay, and then you can
Okay.
download. They will also send you the link. Using that you can download it, right? So this is one way. Other way is we can also download it through Llama. So if I want to download it through the Llama, I don't have to fill any details. Only this command is enough. Okay, so I'll tell you, right? I'll tell you, don't worry. I'll tell you these processes, right? How to use Llama, how to use Gemini, how to use DeepSeek and everything. So you are already using it, but I have to tell you how to use it as a developer, right?
Right. People, just scroll down just for the sake of understanding.
Mhm.
This API,
Mhm.
this would give me an API key
No,
like that.
Llama API is not there as of now. Okay, they're planning to launch API, right? But as of you can see, there is nothing over here. There is no link. No, I click on the this one. It is join the waitlist. Okay, so Llama has not the API as of now, but very soon they are planning to launch it. Okay, so because Llama claim themselves as the open source. Okay, they claim themselves. Okay, but they actually don't pass the open source. There is some criteria for being open source, right? So those criteria they are not passing. Okay, so like who give the open source license? MIT actually gives the open source license, right?
Mhm.
So MIT has not given the open source license to Llama. So Llama has given the open source license to itself. Right, they had
Okay.
if you read its documentation, so they say open source and then this is licensed by Llama. That means Llama had given the open source license to Llama. Right, that is what they did.
Okay. Okay.
So like that's why as they claim open source, that's why they gives you the download option. That means they ask you that you can download into your system, and then you can create all the LLM based application which can run offline without internet. Okay, so because of this feature, that means you can use LLM application, you can create an offline LLM application, that your LLM application will not go to internet, will not do any kind of interaction with the internet. It will just pick information from your system itself. Okay, they say that we are open source, right?
Okay.
So now if I see over here API login and everything, it's not working as of now.
Okay. Okay.
In future they are planning to launch it, but as of now it is not working. Okay,
Okay.
so
Okay.
directly Llama is not giving you the API, but yeah, there are few I don't know what it hang stuck or what happened, but there are what happened, so many things get opened up or what. Okay, so here it's worked. I have to welcome back to the Llama API. So you can just try this thing, join the wait list. So you have to just join the wait list for the API actually. As of now, it
Okay.
is not working. So you can try this, right? And one more thing, but if there are third party is there, some third party websites are there who give the API. One of the third party is this guy, that is Grok, not that uh, Elon Musk Grok. Elon Musk Grok is GROK. Okay, it is
Acha.
GROQ.
Okay.
So this GROQ is there who gives you the API for different open source model. Okay, like when I click here, start
Sorry,
building, you can see. So you can access the API for all these models. Okay, so create API key. Okay, and then they will create the API key for you, right? So it's like it has created the API key. Now, if I go to playground, okay, here different LLM models are there that I can try over here. Okay, API keys. Then we have a dashboard. Pricing. Where is pricing? I want to check pricing actually. Where is pricing thing?
This
Models.
is the free tire that you're working on.
Yeah, this is your free tire, but they also charge. Okay, free tier is this one, great for anyone who started with the APIs, build and test on Grok, community support. Then here it is like for the developers, you have to pay for token. right? So it's like if I click here, right? So it's like it will take my some information, but I just want to check the pricing. Where is pricing? They have pricing also somewhere. Let me check the pricing. Where is the pricing? I can't find it out. Here, if I click, billing is fine. Pricing, yeah, pricing page here. So this is a pricing actually. Okay, like Kimi Llama 4. If I want to use Llama 4 API, so they will charge you $0.11 for 9 million input token. Okay,
Okay.
and the output token it is 0.34 for 2.94 output token. Token means what? Words, right?
Okay.
So that's what, and this is a token per second. This is speed also they are giving. So they are providing it for DeepSeek, Quen, Mistral, okay? Because these are open source model. Gamma is from Google. Okay, Google is having two model. One is Gemini, one is Gamma. Okay, Gemini is closed source, right? Gemini is something that you can use through API. Gamma you can download into your system. Okay, so as they are open source, you can download into your system, but the challenge is only model is something which don't do everything. Your system is processor is also important. Suppose you downloaded a very heavy model, but that doesn't mean that you can do anything, right? You have downloaded a 500 GB of model, but suppose CPU is not that much capable, okay? RAM is just 8 GB. Then what happened? Your system will crash. Okay, because we also required a good GPU, we also required a 32 GB or 16 GB of RAM. So many things are required, right? If hardware is also enough, hardware is also important, right? So in case if you want to use some big size model, but you can't keep it into your system, and that is open source. So through this